Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, check whether BST contains dead end. First of all, let us start by understanding the question. What does question say? Given a binary search tree that contains unique positive integer values greater than 0. So we have a binary search tree and all the values in it are unique positive integers. The task is to complete the function isDeadEnd, which returns true if the binary search tree contains a dead end, else returns false. So we will complete this function. If there is a dead end, we will return true. Your dead end means a leaf node at which no other node can be inserted. Okay, so if out of all the leaf nodes, if there is even at least one leaf node where we cannot further insert a new node either on its left side or on its right side, that is called a dead end. Means from there we cannot expand the binary search tree. So we need to tell whether there exists a dead end or not. Okay. So for example, here the answer would be yes. I am not explaining this example here because we will understand it in concept part. Okay. This is the second example. Here also the answer is yes. You don't have to input or print anything. Complete the function isDeadEnd, which takes binary search tree as input and returns a boolean value. The expected time complexity is big O of n and expected space complexity is also big O of n, where n is the number of nodes in the binary search tree. So now if we think about solving this problem, so first of all, let us understand the term binary search tree. So what is a binary search tree? A binary search tree is first of all a binary tree, means each node will have either no children or one children or two children. Now what is the meaning of binary search tree? Binary search tree means all the nodes in the left subtree of a particular node will have value less than that node, and for a particular node all the nodes in its right subtree will have value more than that node. Okay, so for example, let's say here we have, let's say 50. So on the right hand side, all the nodes in the right hand side subtree will have value more than 50, and on the left hand side subtree with values will be less than 50, and this will be true for all the nodes. Okay, so let's say here we have a node 60. Now for 60, all the values on its left subtree will be less than 60, but make sure they are greater than 50 because the left subtree of 60 will be on the right part of 50. Okay, and the right subtree of 60 will contain values greater than 60. Okay, so let's say now here it is 70, let's say it is 90, let's say this is 65 because it is less than 70 and greater than 60. Okay, let's say here you have 55, then here let's say you have 30. Okay, on the right hand side let's say you have 40, so 40 is more than 30 but less than 50. Okay, on the left hand side let's say you have 20, here on the left hand side let's say you have 10, and here on the right hand side let's say you have 25. So this is a binary search tree. For all the nodes, remember, for all the nodes the condition satisfies that the values in the left subtree of that node has values less than that node, and the values in the right subtree of that node has value more than that node. Okay, so this is a binary search tree. Now what is a dead end? If for any of the leaf node, remember, if for any of the leaf node means who do not have left as well as right child. For any of the leaf node, if I cannot further insert either left child or right child, then it is called a dead end. Also here in the binary search tree, they have said that the values can be unique positive integers only. So they should be unique and they should be positive integers. You cannot take negative or 0. Now let's say, is 10 a dead end? No. Why? Because on the left hand side I can, let's say, insert 7, which is still okay. Even on the right hand side I can insert 12, which is less than 20 but greater than 10. This is also valid. So 10 is not a dead end. For 25, okay, so these are the new nodes added. Okay, let me mark them with green color from now onwards. Okay, these are new nodes added. So this was the original leaf node. This is not a dead end. Is 25 a dead end? No. On the right hand side I can add a value which is more than 25 in the right subtree but less than 30. So let me add 27. Is 40 a dead end? No. I can add a value here, let's say 45, which is greater than 40 and less than 50, right? Is 55 a dead end? No. Why? Let's say I can add a value 51 in the left as a left child. Okay, it is less than 55 and greater than 50. Is 65 a dead end? No. On the left child I can enter the value 63, on the right child I can enter the value, let's say 68. Both of them are valid. Even if you can insert one child, it is not a dead end. If you cannot insert any child, then it is a dead end. Is 90 a dead end? No. Why? Because here let's say you can add 100. Okay, you got my point. So now when can we say that a leaf node is a dead end? Please remember carefully. So whenever the values, let's say for a particular leaf node, the value is I. Then if in the binary search tree, if the values I plus 1 and I minus 1 both exist, then we will not be able to insert further child to I. Okay, so let's have a look at an example. This is also given in the question. So let's say this is 8, this is 7, this is 2, this is 10. Let's say here it is 13 and here it is 9. Okay, now 9 is a leaf node, but 9 minus 1, that is 8, is also present, and 9 plus 1, that is 10, is also present. So now see, in the left child of 9, you want to insert a value which is less than 9, right? Now you cannot insert 8, but you also cannot insert values less than 8. Why? Because this subtree, whatever will be the left child of 9 will be on the right hand side of 8. Are you getting my point? So you cannot insert values less than 8 as a left child, and you cannot insert 8 also. Why? Because it is unique positive integers only. Now if we talk about 10, you cannot insert 10 because 10 is already present. You also cannot insert 11, 12, 13, anything as a right hand side child. Why? Because this subtree is on the left child of 10. So all the values in this left subtree must be less than 10. So if I insert here 11, this will violate the property of binary search tree. So for all the leaf nodes, if we will check whether we get any leaf node whose value is I, and if at any other place in the binary search tree, if nodes with values I plus 1 and I minus 1 exist, then this is a dead end and we cannot add any node further. Another example would be, there is a age case. So let's say that is, we have 5, let's say, then here it is 7, here it is 3, okay, and then here let's say we have 4, here we have 2, and let's say here we have 1. Okay, so whenever 1 is as a leaf node and 2 also exists, remember, for a leaf node with value I, we check for values I plus 1 and I minus 1 if they exist in the binary search tree. Then this will become a dead end. But this binary search tree can only take unique positive integers, not 0, not negative numbers. So whenever a leaf node with value 1 is there, we only check for the presence of 2. We do not need to check for 0 because 0 is not present, neither we can insert it. Okay. So now in the left child of 1, we cannot insert anything because we do not have any valid values smaller than 1. In the right child, I can insert values greater than 1. I cannot insert 2 because 2 is already present. I cannot insert values greater than 2 because this subtree is the left child of 2. So it will have values less than 2 only. I cannot insert a value greater than 2. So ultimately there will be two cases. For all the leaf nodes, if the value of the leaf node is 1, I'll check whether 2 is present in the binary search tree or not. If yes, it is a dead end. If the value of the leaf node is not 1 and some positive integer I, then I will check whether my binary search tree contains I plus 1 and I minus 1 both. If they contain both, I will return yes, it is a dead end. If any of them is not there, let's suppose I is a leaf node and let's say I minus 1 is there in the tree, but I plus 1 is not there. So what I'll do, I'll insert I plus 1 in the right child. Okay, so then it will not be a dead end. Now let's look at its actual implementation. Okay, so if you look at the actual implementation, so I have to complete this function is dead end and root of the binary search tree is passed. Now the values of the nodes are up till 10,001. So I have taken one boolean present array of size 10,002, in which wherever I will find a node with value I will mark present of I as true. Okay. So first of all, I have traversed the complete array and mark present of I as false. First of all, I will fill this present array. So I will traverse the binary search tree using the fill present function, passing the root and present function, present array, and fill the present array. Okay, so let's look at the present function. So if the current root is null, then return, otherwise present of root data plus plus. Okay, whatever be the data, and then I will pass the fill present function recursively. I will call it on root left and root right. Okay, so once my present function is completed, then I will mark my bool answer as false. I will assume that there are no dead ends. Okay, so I have marked my answer as false. Then I have called a function check dead end, which will get root, answer, and present array. Okay, your answer is passed by reference. Okay, if the current root is null, then return. If root left and root right both are null, it means this is a leaf node. So if the value of the leaf node is 1, and if 2 is present somewhere in the binary search tree, then my answer becomes true, there is a dead end. Else means if the root data is not 1 and some other value, then root data minus 1 should be true and root data plus 1 should be true. Then only I can make my answer variable as 1. So if root data minus 1 and plus 1 both are present, then it is a dead end. So I'll mark answer as true. In other cases, I will not mark answer as true even if it is a leaf node. And if it is not a leaf node, I will call the recursively this function check dead end on left and right subtrees. Okay. What will be the time complexity? See, first we will traverse the whole tree once to complete my present array. So it will take big O of n time number of nodes, and second time I will again traverse the whole array to find whether there is a dead end, okay, because I have to go till the leaf nodes. So that will also be big O of n, which will ultimately be big O of n. And what would be the auxiliary space? So here I have this present array which is of the size of n. So auxiliary space will also be equal to big O of n. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.
Hi and welcome to Geeks for Geeks. Today we would be discussing a very easy problem, that is in-order traversal and BST. So if you are new to this tree thing, then this is a medium level problem. But if you are already familiar with BSTs and tree problems, if we talk about tree problems specifically, then this is an easy problem of tree, not an easy problem in general, because BST doesn't really come into the ad hoc problems. Fair enough. This is me, Siddharth Hazra, and let's start off. So let us first see the binary search tree. Let's just say that we have a binary search tree that is 8 and that is 3 and this is 10 and it is 1, that is 6, this is 4 and this is 7 and this is 14 itself. So what do you mean by an in-order traversal? In-order traversal just means that we need to visit the left first and then the root and then the right. How to remember this? Left, root, right. This is how I remember it. So fair enough. Let's just start off. So I just start off basically with the 8 and he tells me that did you visit my left? I said not yet. So I moved on the left of it. 3 is asking me, did you visit my left? I just moved to the left part of it. 1 says that did you visit my left? I said you don't really have a left. So can I visit you? He says yes. So I just visited and that's 10. Now as the left of 3 is visited, we can now visit 3. Now when left and root is done, we go to the right hand side. But if we move to 6, 6 would tell me again that did you visit my left? I say no, not yet. 4 doesn't really have a left, so we can visit it. And then as the left of 6 is visited, we can now visit 6. So now we can visit 6. As left and root is done, we go to and visit 7. 7 doesn't really have a left end. As all the left of 8 is done, we can now take a visit on 8. Now left and root is done, so we can now take a visit on the right hand side. Okay. So right hand side 10 would tell me, did you visit my left? I say 10, you don't really have a left. So can I visit you? He says yes. So I visit 10. And then after left and root is done, we go to the right hand side of it and then we visit it. If you observe that we really have a sorted result, this is an observation. So learn this by heart if you are new to this tree thing and BST thing, that in-order traversal of BST produces a sorted result. And 8 out of 10 questions of BST would be a cakewalk for you. Okay? So now, if it is asked that if the given array is an in-order traversal of a BST is not. So in-order traversal of a BST would be a sorted result. So if this array is sorted, then This is an in-order traversal of BST. I can confirm that. When is an array really sorted? Because BST, binary search tree, contains distinct elements. If it contains distinct elements, then for sure A of I, if this is I, A of I, this is let's say for this that this is I. So A of I minus 1 would be less than A of I. We can say this. And we can do this for all the values. Like we can start from the second element and we can ask if your previous element is less than you or not. If your previous element is less than you or not. If your previous element is less than you or not. So what we can really do is, I'm a very lazy person, would be representing this with lowercase a, and instead of ARR I would be doing it with A. So I would be starting off with a for loop and we would be iterating for int I is equals to 1. Why from the second element? Because we need to do this previous element. Previous element would be present from the second element, not from the first element. So we would be getting index out of bound if we start from the first element itself. So we will be starting off with the first element, I is less than n and I plus plus, and we would say if A of I is less than equal to A of I minus 1. So if this thing is there, then we would return 0. If we didn't find the invalid condition till the very end, then we have true. What is this all about? So if let's say I got into a relationship, I didn't find any red flags till the very end, so the relationship would be, in the end, the relationship would be a success. In the same manner, if I didn't find any invalid condition in all the process, then in the end, it is a perfectly in-order traversal of a BST. Now just compile it and see how many errors are we making, and that's it. Seems cool? And that's it for today. So did you find any notification given? Should I do something after this recording is done? Tell me in the comments, and this would increase the reach of this video and this work could be justified. That's it for today. This is me, Siddharth Hazra, signing off. Thank you. Hi and welcome to Geeks for Geeks. Today we would be discussing a very interesting problem that is again from BST itself, that is brothers for different roots. So my name is Siddharth Hazra and let's move forward. So here the question is very simple. The question is that you are given two BSTs and you're also given a number x, and you need to pick out the elements from both of the BST that sum up to the value x. अर्थात हिंदी में समझा जाए तो आपको दो BST प्रदान किया गया है और आपको एक वैल्यू x भी दिया गया है और आपको हर दो BST से एक एक वैल्यूज लेने हैं. जैसे फर्स्ट BST से x लिया, सेकंड BST से y लिया. x plus y should be the given value. अब let's visualize this with the first example itself. The very first example is 5, then we have 3, then we have 7, then we have 2, then we have 4, then we have 6, and then we have 8 itself. And the very next one is we have something like 10, this one is 6, this one is 15, this one is 3, this one is 8, and this one is 11, this one is 18. Or given value kya hai? What is the given value? The given value is none other than 16. Just remember up this value. So how many pairs are there which sum up to the value 16? So you can see that this 8 and this 8 sums up to the value 16. So I can say that this 8 and this 8 sums up to the value 16. And then we have the very next one, that is this 6 and then 10. So we have something like 6 added to 10, which is also summing up to something as 16. And then the very next one is 5 and 11. Okay, that is 5 plus 11, and that's done. So now how to solve up this problem? The very simple is that you take up the values from, this is let's say B1 and this is let's say BST2, and what you can do is you can keep up the elements in an array. Okay, first we keep up the elements in an array, okay, in two arrays, that is B1 and let's say A1 and A2. A1 would contain the elements of B1 and A2 would contain the elements of B2. So let's say we have something like A1 would constitute the elements like 5, 3, 7, 2, 4, 6 and 8. And A2 would constitute the elements such as 10, 6, 15, 3, 8, 11 and 18. Now what we really need to do is first take up all the elements and store them in an array, and then what we need to do is we need to sort. After sorting, A1 would become something like 2, 3, and then we have 4, then 5, then 6, and then 7, then 8. And A2, after sorting, it would become 3, 6, 8, 3, 6, 8, and then we have 10, 11, 18. 10, 11, I forgot 15, and then 18. After sorting, this would be the result. So the brute force is easy. I just want to append it. What you can really do is for each element, you try to find out like if what is asked. Just keep at this point. So the brute force would be that X is made up of element of A1 and A2. A1 plus A2. A1i and A2j. It would be this. X is made up of this. So if X is made up of A1i and A2j, then what you can really do is we can pick up any element of A1 and try to find the corresponding element in the A2. What I meant is, if you just see up this, the very first one is 16. So we can take up 2 and we can try to find 14. Is 14 present? No, it is not. Then we can go up to 3. 16 minus 3 is equals to 13. Is 13 present? No, it is not. Then we can take up 4. Is 16 minus 4, that is 12, present? No, it is not. Then we can take up 5. 16 minus 5 is equals to 11. Is 11 present? Yes, it is. So what you can really do is, as these two arrays are sorted, if this was not sorted, what you can really do is, you can use a linear search to find the corresponding element. But this sorting things gives us a glimpse that we need to search element a lot number of times. So sorting it and then doing binary search would give better result, because finding n elements is n. Using linear search, it is again n. So for finding one element through linear search, it is n operation. So for finding n elements, it would be n square operation using linear search. But if we just sort it, that is n log n. And at each point, we would be searching the element. So for one search, binary search is log n. So for n search, it would be again n log n for searching all the n values and for sorting it. So it would be 2n log n. 2n log n, n is better than n square. That is why this solution is better than this. Okay, this is the very first thing that you need to do. But there is one more thing that you can do. We took out the elements and then we sorted. Then we had to do the sorting thing. But can we bypass this thing? So bypassing this thing is simple, that we want the sorted result without sorting. So we need to extract the data in such a way that the data is already sorted. What I meant is that अगर मुझे बिना sorting किए sorted result चाहिए, तो मुझे data extraction BST से ऐसे करना होगा कि वो sorted form में ही आए. Make sense? And this gives us a glimpse that the question is of binary search tree, and you should learn this fact by heart, that in order traversal of BST gives us a sorted result. This is for sure true. Just remember this by heart. Okay, so let's just see this in action. 5, 3, 7, and this is, let's say, 2. So in order means left, root, right. So if I go to 5, it would tell me my left is not done. If I go to 3, 3 would tell me my left is not done. So I go to 2, 2 doesn't have any left, so we would visit 2. So we are visiting 2 at this point. Now as 3's left is done, so we would visit 3 as the root. Then it is 2 is done. Now 5's left is visited, so we would visit 5. And then we have the left one, that is 7. So see, we have a sorted result if we do the in-order traversal in a BST. So what we can really do is we can skip up this sorting part. Okay, we can skip up this sorting part and we can directly get the sorted result. But still, the time complexities and log n again. How can we just bypass it more? So getting the sorting thing is now done, but searching the element again and again. So at this point, what the question becomes, that given to sorted arrays, find the number of pairs which sums up to x, which sums up to the value x. This is what is needed, and this piece of cake is a little bit easy to do. How? Let's just write the sorted version of the first BST. That would be 2. Okay, then it would be 3, and then it would be 4, then it would be 5, then it would be 6, and then it would be 7, then it would be 8. This is the very first in-order traversal of the first BST. The second in-order traversal of the second BST would be 3, 6, 8. Okay, then we have 10, then we have 15, no, we have 11, then we have 15, then we have 18. This is the in-order traversal of the second BST. Both are sorted. Now, what we can do is, we can just reverse up this array. Reversing up this array would make it seem something like this: 18, 15, 11, 10, 8, 6, 3. This is the reversed form of the second one. Okay. Now, what we would do is, we would take 2 pointers, I and j. Okay. So now, if 18 plus 2 is equals to 20 and 20 is more than 16, good enough. 20 is more than 16. So we need to lower down our value. If we want to lower down our value, so we need to decrease the value. So if we move this pointer, to that side, the value would increase. If we move this pointer to that side, the value would decrease. So if we want to lower down the value, we would just increase this value, that is 2 and 15. Now 2 and 15 is 17, which is again greater than 16. So we need to decrease the value. So now 11 plus 2, it is less, 13 is less than 16. So we need to increase the pointer. 11 plus 13, again less than 16. So we need to increase the pointer. So 11 plus 14, 15, which is less than 16. So we need to again increase the pointer. So 11 plus 5 is equals to 16. This is the very first time we would be incrementing the count to 1. Initially it was 0. Now both the values are same. They are summing up to 16 and this is done. So now what we need to do is we need to increase both the pointers. So now 10 plus 6 is equals to 16. So we need to increase the pointer and we need to make this go high. Now 8 plus 7, that is 15, it is less. So we need to increase the value. To increase the value, we need to go on that side. Now 8 plus 8 is equals to 16. So we would again increase the value, increase the pointer of both. As you can see, one of the pointers is outside the boundary. So we have nothing to compare. At the end, we have our result. Okay. This is how you would be getting. So we know a way to have the sorted. How to have sorted? By doing in order traversal, that is left, root and then right. But if we wanted a sorted reverse ordering, then what we can do is we can just reverse this, that right would come here and left would come here. So if we visit in this fashion, that is right, root and left, then this would be reverse of this. So for BST1 we would be doing an in order traversal. For BST2 we would be doing a reverse in order traversal. These two functions would be already implemented and then we would be moving forward to the main. Now let's move to the implementation and it would be a feast for you. So this is the in order traversal. We are visiting the left, root and right. Here we are visiting right, root and left, and here we are calling it for BST1 and BST2 and we are saving it in BST1 and BST2. Now what we need to do is we need to have two pointers, int I is equals to 0, comma j is equals to 0. After this we would say while I is for BST1, while I is less than BST dot size. Okay, I is less than BST dot size, and they both should be within the boundary so that we can do a comparison. Okay, so we would say j is less than BST dot size, and here it would be BST2 and here it would be BST1. After all of this we would open a bracket and we would first find the sum. Int sum is equals to BST1 dash I added to BST2 dash j. Now if they both are equal, then we move both the pointers. So we would say if sum is equals to the given value x, we would move the pointer I plus plus and j plus plus. Okay, else if the sum is less than the given value, okay, what we should do? If the sum is less, then we need to increase the upper one. We were increasing this one, so we would increase I plus plus. Okay, if the sum is less. Else if the sum is more, then we need to increase the lower. Okay, because lower pointer is reverse. So if we go on this side, that is 7, 6, the value would decrease. And at the end, this one would also be accompanied with answer plus plus. Okay, now let's just compile and see how many errors are we making. And seems good. Yep, that's great. So what we can really do is talking about the space complexity. Space complexity, we are taking an auxiliary data structure to save the result. The expected space complexity was big of n, so I'm doing it. But my challenge for you is, can you do this without big of n space complexity. Like you can do the iterative in order traversal and this would be done. Now, this is a simple exercise for you. That's it from my side talking about the time complexity. It is big of n. That's it for today. Thank you and have a nice day.
Hey, so let's start with today's problem of the day. Well, today we are having some string. The problem is saying, given a string of digits, the task is to check if it is a sum string. Now, how are they defining a sum string? A string S is called a sum string when it is broken down into more than one substrings, and the rightmost substring can be written as a sum of two substrings before it. All right, and the same is recursively true for substrings before it. Fine. So let's try to understand this problem. Okay, with the help of this example that we have here, this one, we are having a string which is 1, 2, 2, 4, 3, 6, 6, 0. The question is saying that a string is some string only when it follows the particular condition. What is the condition? When we break down the string into substrings, the rightmost string should be actually the sum of previous two, right? So if we check here and consider this 6, 0 as a substring, we can say that previous two substrings, that is 36 and 24, is actually summing up to make 60, correct? When we do 24, 36, that comes out to be 60. So this condition is true for this part. All right. Now, if we have to check it recursively till the end, we can say that let's check for 36. If we go for 36, we can say that two previous ones, 12 and 24. Are these summing up 36? Well, in this case, yes. Right? You have 36, it will be actually 24 plus 12. Fine. And once this is happening like this, we can say that recursively we are coming to an end here because we cannot make sum of only one. We can say that this whole string is actually a sum string. Right? Now, how are we going to approach this problem? Try to think of a solution. We are going to be taking help of recursion. That's true because the question already says that we have to check it that way. Okay, let's take a different variation in which we have different digit sizes, different number sizes. So in this, we have a little variety. We have one digit number, then we have three digit number, then further on three digits, right? So given that we have 1, 1, 1, 1, 1, 1, 2, 2, 2, 3, this as a string. Once we start breaking down, we can see that these first two numbers, this one, only one digit, and then three digits, well, these sum up to be this three-digit number. These sum up to be three-digit number. What is happening here? 1, 1, 1 plus 1, it is becoming 1, 1, 2. And then further on, if we sum up this 1, 1, 1 and 1, 1, 2, we will get this, right? 1, 1, 1 and 1, 1, 2. Then we are having 2, 2, 3. Once this all is, like till the end, we can say that every previous two substrings making up the next substring, we can say that this is a sum string, correct? And what do we have to return? We have to return a bool value, true or false. Depending upon that, the driver code will say output 1 or 0. Okay, now let's try to think of an approach. Let's take the first example only. See, this is a string that we are given, correct? And there is one constraint that a string could be up to 500 like digits. So that means if we consider very big numbers, it is going to go really big in terms of digits, right? So we have to keep that in mind. So for this problem, we have to do it recursively. That means we have to take care of the one part of the question, and else we have to call upon the recursion. Correct. Now, what is the very basic condition that we have to start with? What is the very basic way? What is the base condition? What is the smallest digit we can take? The smallest number that we can take? That is going to be of one digit, right? So let's try to do that. What I'll say, I'll keep one pointer here and I'll say, let me take one length of this. Let me take one length element. Simply let me take one length element. Okay, so I will say from this it will be 1 itself, my first number, and then once this substring ends till the next substring of the same number of digits, that means 1, let's take this one. Okay, so the next number that I would take is going to be 2, right? Now I have two substrings, right? I have to add it up. It will be 3. Is 3 my next substring? Well, here it is not, but how are we going to check it? Are we directly going to compare? Because this could be like not just one digit, because it could be 2 or it could be 3 digits as well. We need to keep a check. So first of all, before directly comparing 3 is lying there or not, we need to check that do we even have a length here? Do we even have the length here that is actually greater than the sum that we have achieved? If yes, then we are going to compare. And once we compare, we can see that here we do not have 3, thus we won't be returning true here. Now, what do we have to do? This call failed. This call failed. That means we are not able to make up a sum string if we are considering one element, right? That means I took this one, I went for 2, then if it would have been true, I would be going on further like this. But this was false, so I stopped there. Now what do I have to do? I have to start a new, or you can say a new choice. That means I'll be taking this 1 with 22. Once we take that, I'll get 1 and 22. This will make up 23. Is 23 long enough that we can check it from the leftover string? Yes, it is shorter than the length of the leftover string. That means we can check it. Once we check it, we again get false, correct? So this whole iteration in which we'll be taking up numbers, 2 or 3 or any number of digits, is going to be false, correct? That means we have to come to the next iteration. And in this iteration, we will be beginning with 2-digit numbers. So this time, I'll take under consideration 1, 2, right? When I take 1, 2, you can see this 24 will be taken. And when I add these two strings up, it will result in 36. I will still check that 36, is it long enough that we can check, is this substring long enough that we can check the summation? Yes, we can. It is 4 and the length of this one is 2. When I come here and I check it, the next 2 digits, actually it is equal. Actually it is equal. Now this condition is passed. We have to return true and we have to carry on the calculation. And what is going to be the furthermore calculation? We are going to check with this. We are going to check from here. We will say 24, we will say 36. Now 24 is my first string, 36 is my second string. I have to add these two. Once these two are added, I'll be having the answer. Then I'll check the answer again. And once I have gotten the answer, just with the check that I've already told you previously, this will return true as well. And when we are getting true till the last, that means we can say that this is a sum string. Fine. And it like this problem will be more clear when we see the code. So let's try to understand the code for it. Okay, first look here. What are we doing? I'm returning, I've just made a utility function, you can say, is some string, and I'm just passing on this string. And what am I doing here? I'm taking up its size. Now I am fixing a loop. Let me just write 1, 2, 2, 4, 3, 6, 6, 0. I'm putting my I here, right? And my j is also going to be beginning from the same place. 1, right? I will be traveling till the end. Okay, now what is I? I will be taking care of the length. Length means the number of digits we are taking at a time. I is beginning from 1, that means we are going to be taking up 1 digit at a time and further on ahead. Then 2, then 3. J is going to go from 1 till I plus j is less than n. Why I plus j is less than n? Why? Because no matter what the longest string is, you would be needing 2 substrings to at least add, right? And further on, the condition will fail that you do not have any more string left to compare the answer with. But still, if you have to add 2 strings, it should at least be 2 halves of the string, of the full string. So I am stopping here. I've taken up this condition that we need to stop here. Now I've made one more function. It is actually checking the main check that I've told you. It is breaking down into the strings and it is summing it up so that we can say that this portion of the string is some string or not. Because if this is some string and further on is still is the sum string, the total will be called as a sum string. So I'm going to make a check till here. Okay, so what am I saying? I'm saying check sum util. I'm passing on the string. I'm passing on 0. Every time the next iteration I make, it is going to be beginning from 0 because I have to check it. 1-digit numbers, I'm going to be beginning with 1. 2-digit numbers, I'm going to be beginning with this position. Then 12, then 122. The first digit will always be included. That means I'm passing this parameter 0 here. That is the beginning of your string. Then I have my I, then I have my j. What is I? Till I have my length 1. Length 1 is the length of first string. Then I have length 2 till j. Till j. This time what is happening? I'm making combination of 1 digit with all the 1 digits. That is why I is also 1, j is also 1. In next iteration, I will be 1, j will be 2. That means I'll be making combinations of 1 digit with all the 2-digit possibles. Once this function call is made, let's see what this function is doing. Okay. This is a bool type function. It is going to be just returning true or false. Depending upon that, our main code, that means this one that we have seen, is going to be returning true or false. All right. Now, if I say, what am I doing here? I am making up my string. So this is my string S1, string 1, and I am just taking a portion of my main string. What is the portion? Beginning. What is beginning? Beginning is from 0. So from 0 till what length? Till 1 length. From 0 till 1 length, if I take, it will be 1, 2, 2, 4, 3, 6, 6, 0. It is just going to be 1. Beginning with 1 and we are just taking 1 length. That means we are just taking up this digit. Now when we talk about S2 and we have to cut one more substring from our main string, what will we do? We will say beginning plus length. That means once the first substring ends, where the first substring ends, we have to pick up the next substring from there. So here I'll say that beginning plus length. That means beginning is 0 plus length is what? Length 1. The length of string 1 is 1. That means I have 1. So from 1 I have to pick up. How many digits do I have to pick up? Length 2 still is 1. So from the first index I have to pick 1 index. If that would have been 2, remember we would be picking 22 because it is only 1. We will be picking just 1 digit 2. So I have 2 substrings. In S1 I have 1 substring, in S2 I have 1 substring. S1 contains 1, S2 contains 2 in the form of a string. Fine. Now what I have done, I want to create one string S3, which is actually will be holding my answer. And I've created one more function here, a string sum S1 and S2. What is the functionality? It will be taking 2 substrings, it will be adding them both, and all the typecasting and will be taken care of. And eventually it will be composing the answer into a string and will be returning back to this S3. So if I am saying string 1 and I am sending a string 2, the answer that I'll get is going to be string 3. Fine. Okay, once that is done, I'll take one variable in which I am storing the length of this answer that I've gotten. Now I have to check, can we compare the answer with the leftover string by the boundary? Because if this is not satisfied, that means our answer is longer than the substring which is left. We do not have to do that. We'll make this check. If this check fails, like that means our summation that we have is exceeding the length of the leftover string, we are going to return false simply from here because that is not going to be the sum string, right? Now let's keep a check here. Once that is inside the boundary, that means my beginning plus length plus L2 is actually equal to my S3. That means what am I doing here? I'm taking up the substring chunk. I'm taking up the substring chunk. The beginning point is going to be this. Beginning from 0. Length of the first string, 1. Okay, done. Length of the second string, 2. That means, hold on. Let me take your ij values of this example only. This example is failing, but let's say I have I to be 1, I have j to be 1. In other words, I have len 1 to be 1, I have len 2 to be 1 as well. We are beginning from 0. What is the length of my first string? 1. What is the length of my second string? 1. What is the total value here? 2. That means my third string, the answer string, will be beginning from this index. That means this one. Okay, and till how many steps do we have to compare? Which is the length of S3. Length of S3 in our case is still 1, correct? Because 3 is only 1 digit. So I'll take like starting from the second index, take one number. It has taken this 2. That means now we are going to compare. Once we compare that, we won't find it equal. Once we won't find it equal, we will simply return false, right? And if we find that equal, that means we need to check that if there is furthermore leftover array, we are going to return true and we are going to make checks for the further on values. Okay, what check am I making here? First of all, I'm just checking that my beginning plus length len2 plus s3. If the whole thing is actually equally becoming the complete size of my string. That means I had this 8, 1, 2, 3, 4, 5, 6, 7, 8 as a complete length. And if I have gotten till here, that means my beginning would somewhere be here at 24, and the length would be len1 will be 2, len2 will be 2 as well. And then when I can say I have 2 plus 2 plus 2, and the answer, that means here S3 len is also of 2. I have all these, then once I add it up, it will become 8, and that will be equal to a string size. This is the base condition. When we are getting till the end, we can say that once we are till the end, we can return true, right? Because if we are reaching it, that means we have covered all these string. Now, what do we have to do? We have to make the recursive call to check the whole array, to check the whole string. We need to make it all for the further on upcoming string as well. What changes am I making? How am I breaking my string up? The string is going to go as it is. Now the beginning point is going to change. Beginning point is going to be beginning plus len1. That means once previously I was starting with 0. Now I'm going to be starting with 0 plus 1. I'm going to be starting with this. Then I'll say len2. Len2 is going to go as it is. See, 3 parameters are there: beginning, len1, and len2. The new beginning is beginning plus len1, beginning plus L1, that is len1. Now len1 is going to be len2, correct? Because see here, let's talk about this example. The first number that we made was 12, and what is the ending of 12? Actually, after that we are going to be starting our 24. And if we talk about the next iteration, 24, 36, 60, 24 will be the first value. That means we have to begin from 24, which was actually the beginning of our second array. Thus, len2 is going to be going to this parameter, and the last parameter will be previous answer. The answer that we have calculated in this call. 36 we calculated in the first call. That is actually going to be my second string. And for that, whatsoever the length is, we are going to tell that. Okay, so I hope you have understood the approach, right? One more thing which we have done abstractly is we have composed this function sum string s1 s2. Well, I would want to just give you guys the implementation of it. This implementation, you can hold on the screen and completely take a look at it. Well, what is happening here is we are adding our let me give you an example. If we have these two strings, we are not just typecasting it and just converting it to number and then adding it and then reverse, like returning it. But what do we have to do? We need to go digit by digit. Okay. If we are receiving 123, then we have to go digit by digit. And just like we do the addition arithmetically, we are going to do that. We are going to take up a carry as well. And in this condition, no carry is there. Okay, let me modify. 7 plus 3 is going to be 10. That means 1 will be recorded as a new result and carry will be there. Then once you simply add it, 4, 5, 6, 7, no carry will be there, carry will be 0. So addition would be 1 and 2, 1, 3 here. 370 would be the new answer string and that will be returned. Why we are doing that, you may ask? Because 500 is the upper limit given to you for your strings. You cannot compose numbers of 500 digits because that is going to be storing getting stored in very big memory, which your compiler might not permit. Okay, now let's try to just check the solution. Okay, so here's the solution that I've just proposed. Let's try to compile that. Okay, so it is giving us the expected output on the sample case that we were taking. Let's submit that and see if it is working for all the other test cases as well. Okay, all right, so it is passing all the test cases. I hope you have liked the approach. Do comment down below if you have any other suggestion or approach to it. And thanks for watching.
So hello and welcome everyone. So in this video, we are going to solve the question minimize the heights 2. This is the problem of the day and the question is very much interesting. The logic behind solving this question is also very much interesting. So let's keep the target of 50 likes in this video, and without any delay, let's start the video. So first of all, let's try to read down the problem statement. So in the question, you will be given an array denoting heights of n towers and a positive integer k. There will be n towers and there will be positive integer k. So for each tower, you must perform exactly one of the following operations exactly once. So you can increase the height of the tower by k, or you can decrease the height of the tower by k. For each and every value in the array, you can either increase it by k or you can decrease it by k. And each and every operation can be applied only once, either of the two one. So now what you have to do, you have to find out the minimum possible difference between the height of the shortest and tallest tower after you have modified each tower. After applying operation on each tower, you have to find out what is the minimum possible difference between the height of the shortest and the largest tower. One note has been mentioned over here that it is compulsory to increase or decrease the height by k for each tower. You have to compulsory apply the operation, and after the operation, the resultant array should not contain any of the negative integers. Okay, so after the operation, the resultant array should not contain any of the negative integers. So now let's try to understand with the help of the test case given over here. So let me just copy this test case and let's try to solve the test case. Okay, so over here the value of k given to you is equivalent to 2 and n is equivalent to 4. And the array elements are 1, 5, 8 and 10. Now either I can increase the value by 2 or I can decrease the value by 2. So these are the two operations from which I can apply. I can either apply this or this operation. So now what I have to do, this is the entire array. So first of all, before applying the operation, let's try to find out the difference between the smallest and the largest element. So the smallest is 1 and the largest one is 10. So 1 and 10, and what is the difference? So 10 minus 1 will be equivalent to 9. Now what I will be doing one by one, I will be either applying plus 2 or minus 2 on each and every array element. So let's start with the first element. What if I apply minus 2 on 1? So it will be a negative value, right? So I cannot apply minus 2, I need to do plus 2 for this one. So it will be equivalent to 3, right? So I have done plus 2 on this one and I can see the value becomes 3. For now this 5, what I will be doing, I will be trying to decrease the value by 2. So 5 minus 2 will be equivalent to 3. Now for this 8, again I will be trying to decrease the value by 2. 8 minus 2 will be equivalent to 6. And for this 10, what I can do, I can increase the value or decrease the value. See, the target is to minimize the smallest and largest, the difference between the smallest and largest element, right? Now for this 10, if I increase the value by 2, so 10 plus 2 will be equivalent to what? It is equivalent to 12. So the largest element over here will be 12, but I don't want this. I want to minimize the difference between the smallest and the largest one. So instead of applying plus 2, I will be doing minus 2 for 10. So 10 minus 2 will be equivalent to 8. So now over here in this modified array where I have applied each operation at least once, so what is the smallest one? 3. And what is the largest one? It is equivalent to 8. So 8 minus 3 will be equivalent to 5, and this is the smallest possible difference between the smallest and the largest element, the minimum difference possible. So if you try out different other combination of doing plus 2 or minus 2, you will not be able to minimize this value. And now what will be the output of this test case? The output of this test case comes out to be 5. And you can check inside the output of the example number 1, the output is also equivalent to 5, right? So this is the entire question, and in this manner you have to choose either plus k or minus k for each and every array element. And if you do so, you will be getting a modified array, and you have to find out the difference between the smallest and the largest element. So this is how the entire question works. I hope you understood everything about the question. So now let's try to brainstorm and let's try to understand how to solve this question. What can be the algorithm of solving this question? So now, before starting and before understanding the optimal approach, what I'll be doing, I'll be going through the brute force approach. What can be the brute force approach? So in the brute force approach, you might have already guessed, you can apply both the combination. You can try out plus k and minus k for each and every array element, We know how many array elements are going to be there. There are n array elements, right? And for each and every array element, I have two operations. I can do either plus k or minus k. So now what will be the time complexity if you try out each and every other combination? So the time complexity will be around 2 to the power n. It will be exponential, right? So the brute force approach, if you have thought of doing the brute force approach, it will be not feasible. It will not be accepted because it is going to take much amount of time. So now we strictly need to be on the safer side, and we need a different approach, which will be far better than this exponential approach. So now for this approach, what I need to do? See, first of all, as I mentioned, for each and every element, you have two options available. You can either do plus k or you can do minus k, right? You can either do plus k or minus k. So there are two different possibilities. So now over here, if you try out each and every possibility, this is not going to work. You need to act little bit smartly so that you can easily solve this question. So let me explain you what can be done. So over here, let's say this is the entire array, and this is the array in which I have already sorted this entire array. Okay, so now let's say after sorting the array, this is the entire array. So A is the smallest element and B is the largest element, and there are different elements between A and B. So now on the number line, if you try to observe A and B on the number line, so here will be your A and here will be your B, and all the other elements will be lying between this range A and B, right? So now if I want to decrease the value, if I want to minimize the difference between A and B, before applying the operation, the difference will be B minus A. Do you guys agree? Before applying the operation plus k or minus k on every array element, the difference is going to be B minus A. Now, if I want to minimize this entire difference, what I can do, I can somehow bring the value of this A on the right hand side, and I can somehow bring the value of this B on the left hand side. So if I want to bring the value of this B, if I narrow down this entire range to something like this, earlier it was this range. Now if I narrow down this range into this much, so if I apply plus k, to this A, and if I apply minus k to this B, I can narrow down this range. Do you guys agree? So if I do plus k, if I do A plus k, and if I do B minus k, the difference between the largest and the smallest one will be reduced now. If you want to check the difference, so B minus k minus A plus k, what will be the value? So that would be B minus k minus A minus k, and that comes out to be B minus A minus 2k, right? So this is the value, and obviously earlier what was the value? Earlier the difference was B minus A, and now what is the difference? After narrow down the entire range, the difference is B minus A and minus 2k. I'm subtracting something extra from this the range. So obviously the difference has been reduced down. So now what I will be doing? So I will be keeping the smallest value. I'll be having two different variables. The smallest one will be what? It will be nothing but it will be B minus A. So basically the smallest value will be what? It will be A plus k. And the largest value, what will be the largest value? So the largest value in this scenario will be B minus k, right? So for the first element and for the last element, I have made sure that this is the most feasible option which I can do. I can either increase the value of A for the smallest one, and I can decrease the value of the largest element by k. So I have got two different values for the first element in the sorted array, and for the last element in the sorted array. I have figured out that this is the thing which I can do. I'm not sure whether this is correct thing or wrong thing, because it is possible that if I'm going to modify the elements present in this range, if I'm going to modify the other values, then it might appear the smallest might change to something else. The smallest might change to something else, and the largest might change to something else. It is possible, right? So now this is the first thing. So the first thing what we are going to do, the first thing is that we are going to sort the array. So on sorting, I will be getting a range. A to B will be my range. And now after that, I came to know that I have the smallest and the largest element. And what I did for the smallest and the largest element inside the sorted array, I was able to figure out that what will be the smallest value. So the smallest value will be A plus k after applying the operation, and the largest value will be what? It will be B minus k after applying the operation. For A and B, I have figured out what I can do. Now, what can be done further? So the further thing is that for for these two values, I have identified, okay, so this can be the thing. Okay, so now over here, there will be one answer variable available, right? See, I need a variable that will store my final answer. So what should I initialize this answer variable? Let's try to think for a few minutes. Let's take one example. Let's say all the array elements are 1 in this case. Okay, and let's say this is the entire array. The value of n is equivalent to 4 and the k value given to you is equivalent to 3. Now on this entire array, can you apply -3? Can you decrease the value of each and every array element by 3? Is it possible? Do you think it is possible? Obviously not. If I apply -3, then all the array elements are going to be negative. And according to the quotient, I cannot have any negative values inside the array. Fine. So what will be my option? What I can do? So if before applying the operation, before applying -3 or +3, what is the difference between the largest and the smallest one? So that difference is answer is equivalent to 1 minus 1, and that answer, temporary answer, is equivalent to 0, right? So now over here, what I can do? I can simply apply +3 on each and every array element. I can apply +3 on each and every array element. So the array will become 4, 4 and 4. So now what is the difference between the largest and the smallest one? So the difference between the largest and the smallest one is 4 minus 4 is equivalent to 0. I cannot see any change in the answer. Earlier also, before applying the operation, it was 0, and after applying the operation also, it is equivalent to 0. So there might be some of the test cases in which the answer remains unchanged. So what I will be doing, whichever answer variable I will be having to store my answer, I will have that answer variable initialized to the difference of the largest and the smallest element. That will be initialized to difference of the largest and the smallest element. Okay, and over here, A is the smallest one and B is the largest one. A is the what? Smallest element, and B is what? It is the largest element. Okay, so do not confuse yourself. So this is A and this is B. Basically, you can do largest minus smallest element. It is largest minus smallest. So I will initialize my answer variable with what? Largest minus smallest. And this is the proof that I can initialize it in this manner, right? So now we have understood, okay, so these are the things, and for two elements, I was able to predict, after sorting the array, I was able to predict for the smallest one and for the largest one, that for the smallest one, what I can do, I can increase the value by k, and for the largest one, I can decrease the value by k. This is the entire prediction for these two elements. Now, what can be done for the rest of the array elements? Now, what can be done for this many elements? So now here comes an intuition. Here comes very interesting part. Let me take one more example. Let's say it is 1, 3, 5 and 7. Okay, and now for this array, let's say n is equivalent to 4 and k is equivalent to what? K is equivalent to, let's say, 4. Okay, so now over here, for this element, for this entire array, what I will be doing, first of all, let's say to initialize the answer variable. What can be the answer over here? 7 minus 1 will be equivalent to 6. So this is my initialization of the answer, right? This is the answer. That is basically the difference between the smallest and largest before applying any of the operation. Fine. So now for n is equal to 4 and k is equal to 4. So now if I apply the operation for this element, can I do plus k? Basically, can I do minus k for the first element? Can I do 1 minus 4? No, I cannot do 1 minus 4. So what can I do? I can simply do plus 4. Similarly, for this 3, can I do minus 4? So 3 minus 4 is equivalent to minus 1. I cannot do minus 4 for this element as well. I can simply increase the value. But after this point, for this 5, can I do plus 4? Obviously, you can do plus 4. And can I do minus 4? Obviously, you can apply plus 4 and minus 4, both of them. Both of them are possible, right? So now over here in this scenario, there is a pivot point. There is a pivot point that before the pivot point, all the elements can only have plus k operation on it, right? Over here, this was the pivot point. That before, in this range 0 to I, all the elements can only handle plus k as an operation. It cannot handle minus k as an operation. So now over here, what I will be doing, I will be iterating over the pivot point. One by one, I will be checking whether, let's say if this is my pivot point, then what will be my minimum and what will be my maximum element. Okay. So how will I find what will be my minimum and what will be my maximum element? So whenever I say this is my location of the pivot point, you have to understood that all the elements in 0 to I have been applied plus k operation, and all the elements from I plus 1 to n minus 1 have been applied minus k operation. Because it is possible that some of the elements cannot handle minus k in the range 0 to minus 1, in 0 to I, right? So this is what I'll be doing, that I'll be iterating over each and every array element from 0 to n minus 2, that is the last element, 0 to n minus 1, basically 0 to n minus 2, that is the last element, and I'll be finding that what will be my minimum and maximum element in that scenario. So how to find the minimum and maximum element? So this is the entire sorted array, right? So every element will be in increasing order in this manner, right? So this will be the entire building height. Let me draw it in a clear manner. So let's say this is the element, this is the element, this is the element, and this is the element, and this is the element, right? So now initially, what is the smallest element? Smallest one is this one, the smallest one. And what is the largest element? This is the largest element, right? Now I have to apply the operation. And now let's say for this was my pivot point, this is my pivot point. So in 0 to I, what I can do, I can only do plus k. So the range, so the value of the buildings, basically the height of the building might have been increased to this, and this might have been increased to this much, right? So now in this scenario, it is possible that your smallest and the largest element might have changed. So what can be the smallest and the largest element? That is, what can be your minimum element and what can be your maximum element. So initially your smallest is this one. Smallest is the first element and the largest one is this element, right? So basically your smallest will be what? It will be array of 0 plus k, and your largest element will be what? Array of n minus 1 minus k, right? As I explained that these are the two predictions which I can do on the first and the largest element, smallest and the largest element, right? So now how to find the minimum and maximum after applying? Let's say if this is my pivot point, there will be changes in the minimum and the maximum element. So minimum will be what? It will be what? It will be minimum of the smallest element and array of I plus 1 minus k. So what I did over here, see, I said that this is my pivot point, my I is over here, right? So all the elements from 0 to I minus 1, I have assumed that I have done plus k to them. I have applied plus k operation. So all the elements in this range can be done minus k. I have applied minus k operation on all of them, right? So now what will be changes in my smallest and the largest element? So it is possible if I do plus k over here on each and every array element, if I do minus k on each and every array element from I plus 1 to n minus 1. So let's say this will be reduced to this much, and this will be reduced to this much, this will be reduced to this much, and this will be reduced to something this much. So this much part will be deleted from every array element in the range I plus 1 to n minus 1, if this is the scenario, right? So this will be the reduction done. So now what will be your maximum and minimum value? What will be your maximum and minimum value? So your maximum in this range, what will be your maximum value? Your maximum value will be the last element. It will be array of, your maximum value will be array of this element. Basically your maximum value will be the last element. What will be the smallest one? So the smallest one will be what? It will be array of I plus 1 minus k. So I have reduced minus k from the I plus 1th element, and in this range, in this part, in this much of part, the smallest element will be array of I plus 1 minus k. I am comparing this value with the smallest which I have predicted, that is this one. Similarly, in the same manner, I have to find out the maximum value. So these are the initial values, right? This is the entire sorted array. Okay. Now let's say this is your pivot point, and in the pivot point, here is your I, and all the elements from 0 to I minus 1, what are they applied? They have been applied plus k operation, and all the elements in I plus 1 to n minus 1 have been applied what? I have been applied minus k. So assume that I have applied minus k on all of them. So the value of every array element from I plus 1 to n minus 1 will be this much, right? So these are the new values after applying the operations, right? And over here, after applying plus k operation, the new value will be this much, right? So these are the new values. So now I have to find out what can be the maximum value. So I have explained what is this mi, what is the minimum value, that is minimum of smallest and array of I plus 1 minus k. Now what will be maximum? Maximum, let me help you to understand what can be the maximum. Now I want the answer from you guys. Try to think what can be the maximum. See, initially this is my smallest and this is my largest. And we know smallest is what? It is basically array of 0 plus k. And what is the largest one? Largest is array of n minus 1 minus k. As I explained that the range will be reduced down. I have predicted the plus k or minus k for the smallest and largest element, right? So now over here, I have to find out what can be the maximum. If my maximum might have been updated, it is possible that your largest element remains this largest element, right? It is possible that this largest element remains as it is. So one of the candidate will be what? One of the candidate will be largest variable itself. It will be largest variable itself. And over here, in this range, which is the largest element? In this range, the largest element is this one. It is what? It is array of I plus k. So basically, I have reduced minus k from this element. The element standing at the pivot point. So maximum will be updated to array of I plus k. So maximum of these two values will be your updated maximum value after applying the operation. So this will be the updated maximum and minimum at each and every pivot point. And now you can update the value of the answer variable to what? Answer variable will be nothing but answer variable will be minimum of answer and updated maximum minus minimum. So this is how we can find the answer. But now one more thing we need to handle. See, as I mentioned, as I'm doing minus k, it is possible that the value of this mi, this value of array of I plus 1 minus k might have been reduced down to negative. So in order to handle that, the value of mi is negative. If the value of mi is negative, then I will not apply this formula. I will simply continue. I will not apply this formula because if mi is negative, let's say mi was equivalent to 10 and mi is equivalent to minus 9. So 10 minus 9 will be 19. It will not be a smaller value. And obviously, according to the question, that thing negative element is not accepted in the operation, right? So this is the entire algorithm. This is the entire thing what we will be doing. And now let me try to summarize the entire algorithm. I hope you understood it. This was a little bit complex, the understanding part, but let me just quickly write down the entire algorithm. Okay, so this is the entire algorithm. So the first step is to sort the entire array. So after sorting the array, what I need to do? I need to find the answer variable. So what will be the answer variable? As I mentioned, for some of the test case, you might be applying only plus k operation. If you apply plus k on each and every array element, the difference between the largest and smallest before applying the operation and after applying the operation is not going to change. So that would be array of n minus 1 minus array of 0. And now I need the smallest and the largest element. What will be my smallest element? Smallest element I have predicted for the 0th element, for the array of 0th element. I know one operation what I can do. I can just do plus k, right? So reducing down the range of the elements. So array of 0 plus k will be the operation. That will be my smallest element, and largest element possible is array of n minus 1 minus k. So this is the smallest and largest element. Now I need to work on the pivot element. So on the pivot element, I am assuming that all the elements from 0 to the pivot element, basically from 0 till I, for all these elements, what I will be doing, I will be simply increasing their values. And for all the elements from I plus 1 to n minus 1, I will be simply reducing down their values by minus k, right? So I will be having a for loop that will be starting from I is equal to 0 to I is lesser than n minus 1. I am not iterating till the last element. You will come to know why I am not iterating, because according to this formula, that is, now your mi might have been updated, the minimum value element and the maximum element might have been updated. So minimum will be what? Minimum will be nothing but minimum of the smallest element which you have predicted and array of I plus 1 minus k, And what will be the maximum value? So maximum will be maximum of largest element and array of I plus k. In this range, in 0 to I, if I applied plus k on every element, what will be the largest element? So the largest element will be array of I plus k. So I have compared it with the largest which I have predicted. And in this range, in I plus 1 to n minus 1, if I applied minus k on every element, then what will be the smallest element? What will be the smallest element? It will be what? Array of I plus 1 on which I have done minus k. This element will be the smallest one because the entire array is sorted. So this is the reason why you need to sort the entire array. So let me just put this little bit far away from the algorithm so the algorithm looks prettier. It would be cleaner. Array of I plus k. Fine. And this entire logic is for what? It is for the pivot element. Okay, so let me copy this over here. Now what I need to do, I need to check if I have done negative element, if I have handled negative element or not. So if mi, that minimum element, is lesser than 0, I will not apply the formula. I will just continue from here itself. And if this is not the scenario, answer will be what? Answer will be minimum of the answer which I have already found and the difference between the maximum and minimum value, right? And the fifth step is to simply print or return the answer variable. Fine. So this is the entire algorithm. This is the entire algorithm. And I hope you have understood the entire algorithm. Okay. So what will be time and space complexity of this algorithm? So the time complexity will be sorting, that is order of n log n plus order of n, but I am ignoring the order of n. So the overall time complexity will be order of n log n. What will be the space complexity? Space complexity comes out to be constant. So this is your time complexity and this is your space complexity. Okay. So try to take one more test case and try to understand how this entire thing is going on. I have shown you different test cases, that why we need to do this and this step, right? So now let's move and let's try to understand what is the implementation part. So over here I have implemented the entire algorithm in Java, but the same can be implemented. Take the reference of the algorithm and you can implement it in whatever language you want. Okay, so here is the first step of the algorithm, that is sort the entire array. So answer variable will be what? Initialized to array of n minus 1 minus array of 0, that is largest minus smallest difference. And now I have two different values, that is smallest and largest. I have predicted for the first element it will be plus k. I am applying array of 0 plus k. And for the largest element, it is possible that the last element remains largest. So I have done minus k on that element. And now these are the local variables mi and ma, that is minimum and maximum based on the pivot element. So now for the pivot element, I have iterated from 0 till n minus 1, that is till the second last element. Okay, so mi, that is minimum, current minimum. What will be the current minimum? It will be nothing but the minimum of the smallest which you have predicted and array of I plus 1 minus k, that is I plus 1 to n minus 1. In that range, what will be the smallest element? It will be array of I plus 1 minus k. And what will be the maximum element? Maximum will be the largest which I have predicted, and in the range 0 till I, the largest one will be array of I plus k. So after doing that, I have handled the case in which the negative elements might be possible. So if negative element is possible, then I am just continuing. I will not update the answer variable. And now if it is not the scenario, then answer will be updated to what? Answer will be updated to math.min, basically minimum of answer and difference between current maximum and current minimum based on your pivot point. And at the end, you have to simply return the answer variable, and that's it. So now let's try to submit this entire solution and let's have a look at the acceptance. And we can see that the problem has been successfully submitted. So that was it for in this video. I hope you understood everything about the solution. And this question was kind of trickier, but we need to keep in mind different algorithms. Basically, we need to keep in mind different test cases to understand. And I have shown you the example of every test case, why we need to do this and that thing. So that was it for in this video. Thank you for watching. I'll see you in the next video. Bye-bye.
Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is how many x. First of all, let us start by understanding the question. Given two integers L and R and a digit X. Find the number of occurrences of X in all the numbers in the range L to R excluding L and R. So basically, see, we will be given three integers L, R and X, and for all the numbers between L and R excluding L and R. So for all the numbers from L plus 1 to R minus 1, we need to tell how many times the digit X has occurred in between. Okay. So for example, let's take L equals to 10 and R equals to 19 and X equals to 1. So we need to tell how many times the digit 1 has occurred from 11 to 18. So here it is 2 times, here it is 1 time. So 3, 4, 5, 6, 7, 8 and 9. So the output is 9. Okay. Digit 1 has occurred 9 times in this segment. Okay. Similarly, you can calculate for this. You don't need to read input or print anything. Your task is to complete the function countx, which takes three integers L, R and X as input parameters and returns the number of occurrences of X in the range from L to R, while L and R are excluded. The expected time complexity is R log R and expected auxiliary space is constant. So now if we think about solving this problem, so what we can do here is, see, we are given two integers L and R. So let me take L as let's say 810 and R as let's say 910, and I want to tell how many times the digit 1. Okay, so this will be equal to X. How many times a digit 1 has occurred from this range to this range. Okay, so what I will do, I will traverse one by one from 811, 812, 813 up to 909, and for every digit I will count the number of occurrences of 1 in that digit and sum it up. That will give me the answer. Now, how can I calculate the number of this digit X in one number? So let's take this example, 811. So what I will do, every time I'll compare the unit place digit with my X, and if it is equal to X, I'll increment the counter and then divide this number by 10 until it becomes 0. So for in the first time, I will say what is the unit digit. How will I get unit digit? I will take modulo 10. Okay. So this will return me 1, that is the unit place digit. So it is equal to 1. So I'll increment my answer counter. Okay. Then I'll divide it by 10. So here the unit place digit is 1. Then I'll divide it by 10. It will become 81. Again, I'll take modulo 10. The unit place digit is 1. Again, I will say answer plus plus because it is equal to X. Again, I'll divide it by 10. It will become equal to 8. Now the unit place digit is 8. It is not equal to X. So I will do nothing. I'll again divide it by 10. It will become 0. So I'll move on to the next digit. Okay. Now how much time complexity it will take? See, we are moving from L to R. So the upper bound what I can give is what? R. The for loop will be from L plus 1 to R minus 1. So big O of R means what? A for loop of size R from 1 to R. So this is an upper bound. And one digit will take how much time? So the biggest digit is R. Okay. If we think, then the number of divisions required until before this number becomes 0 is log n base 10. Okay. Because we are dividing it by 10 at every step. So this many steps will be required to calculate number of X in each digit, and the highest value of n can be R. Okay. So in order to give an upper bound, I can say R log R base 10. Okay. This will be the time complexity, and what will be the auxiliary space complexity? As such, you will not need anything. So it will be constant. Now let's look at its actual implementation. So if we look at the actual implementation, so what I have done, I have taken one answer variable which is equal to 0, and I traversed from L plus 1 to R minus 1, and I have initialized j equals to I. Now I'll keep dividing j until it is greater than 0, because for every I need to count the number of X, right? So while j is greater than 0, if the unit place digit is equal to X, then do answer plus plus, and at every step divide j by 10, and finally return the answer variable. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, my name is Karan Masu. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is number of subarrays with maximum value in given range. First of all, let us start by looking at the question. What does question say? Given an array of n elements and L and R, print the number of subarrays such that the value of the maximum array element in that subarray is at least L and at most R. So basically we have an array of n elements, and we want to find the number of subarrays in which the maximum value of that subarray is between L and R. Okay, so if we look at this example, so here there are 4 subarrays where maximum value of that subarray is between 1 and 10, including 1 and 10. So one subarray is 2, 2 is between 1 and 10, another subarray is 2, 0, the maximum value in 2, 0 is 2, which is between 1 and 10. Another subarray is 3, where 3 is between 1 and 10, another subarray is 3, 0, where the maximum value of this subarray is 3, which is again between 1 and 10. So the number of such subarrays where the maximum value of that subarray is between L and R is 4. Okay, similarly you can have a look at this example. This is a function problem. The input is already taken care of by the driver code. You only need to complete the function count subarrays that takes an array ARR, size of array n, element L and integer R, and return the number of subarray with maximum value in range L to R. The driver code takes care of the printing. The expected time complexity is big O of n and expected auxiliary space is constant. So if we think about solving this problem, then here we need to tell the number of subarrays. So let's say there are n elements in the array. Okay, let's say for this example there is n equals to 5. So what is the total number of subarrays? The total number of subarrays is n into n plus 1 divided by 2. So in this case it would be 15. Now out of all these subarrays, I need to return the number of subarrays where the maximum value of that subarray is between L and R, means it is between 1 and 10 included. Okay, so the maximum value of a subarray is between 1 and 10. I need to return such subarrays. So now tell me, can I have any such subarray in which any element is greater than R? No, because even if it is not maximum element, or even if it is maximum element, if the element is greater than R, then the maximum element of that subarray will also be greater than R, right? So those subarrays will not be included. Also, I do not want the subarrays where the maximum value is less than L, right? I want the subarrays where the maximum value is between L and R. It means that I cannot have any element which is greater than R, but I can have elements which is less than L given there is at least one element between L to R and no element greater than R. Okay, so now what is the easier way to do this? So what I can do is I can count the number of subarrays where values are less than equal to R minus number of subarrays where values are less than equal to L. See, if I calculate the number of subarrays when values are less than equal to R, then I will have such subarrays where all the values will be less than equal to R, and so here I am trying to calculate the number of subarrays where, okay, just a second, this will not be less than equal to, this will be less than L. Okay, so here I will calculate the number of subarrays where the maximum value is less than equal to R. So this will return me all the subarrays, the number of subarrays in which the values are less than equal to R. So the maximum value is less than equal to R means it can be even less than L. But such subarrays I do not want. So if I subtract the number of such subarrays where maximum value is less than L, means the maximum value is up till L minus 1, then the remaining answer would be the number of subarrays in which the maximum value is from L to R. Remember, it can contain values smaller than L, okay, but the maximum value in that subarray should be between L and R. Now how can I calculate these values? So this is very easy. So if I want to calculate the number of subarrays with values less than equal to R, let us take this example. So I have 2, 0, 11, 3, 0, okay, and I want to calculate the number of subarrays where values are less than equal to N. So I will take a left pointer equals to 0 and right pointer equals to 0. And I will keep incrementing my right pointer until the values are less than equal to 10. So R is 2. So 2 is less than equal to 10. So my R will come here. Now 0 is less than equal to 10. Yes. So my R will come here. Now 11 is less than equal to 10. No. It means this is not a valid member to add in the subarrays counting of this. Means I started from L and I ended at R. So from L to R minus 1, all the elements are less than equal to R. from L to R minus 1, all the elements are less than equal to R. So the number of subarrays from L to R minus 1 will be added to my count of subarrays where value is less than equal to R. So the number of subarrays from 0 to 1 is how much? 3. This alone element, and this both together. Okay. 2, 0 and 2, 0. In general, how can I calculate? If I want to calculate the number of subarrays between L and R minus 1, the total number of elements between L and R minus 1 is how much? R minus 1 minus L plus 1, that is R minus L. And if the number of elements in this subarray is R minus L from L to R minus 1, then the number of subarrays will be J into J plus 1 divided by 2. Okay. So I'll calculate the number of subarrays which can be formed here, because here all the elements are less than equal to R, and add it to my answer. Then this was the point where the element is greater than R. So I will move my starting pointer to here. Okay, L equals to R plus 1, and also move my R here. Now again, this is equal to R, less than equal to R, 3 is less than equal to 10, yes. So my R will go here. 0 is less than equal to 10, yes. So my R will come here. Now I come outside of the array. So my L finally is how much? It is pointing to 3. So it is equal to 3. Like this index is also 3. Okay, 0, 1, 2, 3. And my R is equals to 5. It has come outside. So from 3 to 4, I need to count the number of subarrays, because these contains the values less than equal to R. So from 3 to 4, there are 2 elements. So again, there will be 3 subarrays. 3 alone, 0 alone, and 3, 0. So again, 3 subarrays. Here also there were 3 subarrays whose value was less than equal to R. Here also there are 3 subarrays whose value is less than equal to R. So this became equal to 6. Now I want to calculate the number of subarrays with values less than 6. So I repeat the same process, but now instead of less than equal to R, I include the elements in the subarray where values are less than L. Okay. So it is 2, 0, 11, 3, 0, and value of L is 1. So my L is here and R is here. 2 is less than 1? No, it should be less than 1. Okay. L is 1. So my L will go here and R will also go here. 0 is less than equal to less than 1. Yes. So my R will go here. Now this is less than 1. No. So my L value is 1 and R value is 2. So I want to count the number of subarrays from L to R minus 1. That is from 1 to 1. That is nothing but 1. So there is one subarray which contains where maximum value is less than L. This is the alone subarray. Similarly, when I'll move forwards, I will get one more subarray where value is less than 1. Okay. So there will be 2 such subarrays. So 6 minus 2, the number of subarrays where the maximum value is between L and R will be 4. Now let's look at its actual implementation. So if I look at the actual implementation, so I have array A, number of elements in the array, and L and R given in the input. I have taken L and R 0 because I want to traverse the array and count the number of subarrays, and I have taken some variables. Initially answer equals to 0, and I have taken 2 variables S1 and S2, but basically I have not used S1 and S2. Okay, so look here. So let's start from here. What I have done here is I have counted the number of subarrays where the maximum value is less than equal to R. So initially L is 0 and R is 0. If the value of A of R is less than equal to R, do R plus plus. Else, number of subarrays, number of elements from L to R minus 1 is J, that is equals to R minus L, and the number of subarrays between L to R minus 1 will be J into J plus 1 by 2. So this will be the number of subarrays. So when I get an element greater than R, I first calculate the number of subarrays which can be formed from L to R minus 1 where value is less than equal to R, and add it to my answer, and do L equals to R plus 1 and R plus plus, and then again repeat the process. Also, after I come out of the loop, I again calculate J equals to R minus L and answer equals to answer plus this. Why? Because as we saw in the last example, if we look here, so finally when we came out of the loop, my L was pointing here and R was here. So the subarrays due to this needed to be added to the answer. Okay. So I add it to the answer. So this portion will give me the count of the subarrays in which the maximum element is less than equal to r. And this portion, this is the same portion as this. You see L equals to 0, R equals to 0 to N, everything is same, just two changes. Here A of R is less than L, then I do R plus plus. So here I'll get the count of subarrays where the maximum value is less than L, and I need to subtract that count. So here also there is subtract sign, and here also there is subtract sign. So here I subtract the count of subarrays where value is less than, maximum value is less than L, and here I add the count of subarrays where maximum value is less than equal to R. So their difference gives me the count of subarrays where the maximum value is between L and R, and finally I return the answer. What is the time complexity? I am using two for loops, so time complexity is big O of n, and what is the auxiliary space? It is constant. Okay, now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is transform to prime. First of all, let us start by understanding the question. What does question say? Given an array of n integers, find the minimum positive integer to be inserted in array so that sum of all the elements of the array becomes prime. So basically we are given an array of n integers and we need to tell what positive minimum number we can insert to an array so that sum of all the elements of the new array, that is all the elements of the old array plus the new element which we inserted, that sum value becomes prime. Now one thing which I would like to tell you here is that it is said minimum positive number, so ideally it should start from 1, but for the test cases which are given in the question, 0 is also allowed. Okay, so let's look at this. For n equals to 5, let's say these are the 5 elements, so the sum of these elements is 32. Now what is the smallest number which we can add to 32 so that it becomes prime? Is 5. When you add 5 to the array, the total sum becomes 37, which is a prime number. Okay, similarly here the total is 13 and you do not need to add anything. 13 is already prime. You don't need to read input or print anything. Your task is to complete the function minimum number that takes array and integer n as input parameters and returns the minimum positive number to be inserted in the array so as to make it sum a prime number. The expected time complexity is n log n and expected auxiliary space is constant. So now if we think about solving this problem, so basically see, we are given n elements in the array and we need to tell what minimum element can we add new to the array such that summation of the array elements plus that new element, this total sum becomes prime. Okay, so we need to tell what this new element can be. It can be any integer greater than equal to 0. Now in the question it is also said that the sum of elements of the array is less than equal to 10 to the power 6. Okay, and the expected time complexity given is n log n. So what we can basically do is, using sieve of parenthesis, we can find out all the prime numbers from 0 to 10 to the power 6 log 10 to the power 6 time. Okay, so how does it work? So basically we take a prime array of size 10 to the power 6 plus 1 and mark all of them as 1 initially. If p of I is 1 finally, it means it is a prime number. If p of I is 0 finally, it means it is not a prime number. Okay, so initially we assume all of them are prime numbers. Then we mark 0 and 1 as non-prime numbers. And then from 2 onwards, what we do is we run a loop from 10 to the power 6. Okay, so I equals to 2 till I square is less than equal to 10 to the power 6, I plus plus. Okay, and if p of I is 1, it means if I is a prime number, then what we do is we run another for loop from I square to 10 to the power 6. Okay, and j plus is equals to I. Basically all the multiples of I starting from I square. So if I is a prime number, we mark all the multiples of I starting from I square. So I square, then we do plus I. So I square plus I square plus 2i. All of them we mark as p of j as 0. Why? because if I is a prime number, then its multiples are not a prime number, right? We are not going to go in the proof of this, but this basically runs in 10 to the power 6 log 10 to the power 6 time, okay? And it will basically mark all the elements whether they are prime or not in the array P, okay? Then what we can do is, so for example, how it works is basically, let's say we have 11 elements, okay? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? So first of all, it assumes all of them to be prime, and then it marks 0 and 1 as not prime, okay? So I'll mark 0 in this and all of them as 1, okay? So these are all prime numbers, okay, where finally we would get 1. Now starting from I equals to 2, if P of I is 1, means 2 is a prime number. Starting from I square, I'll go up to 10 to the power 6. Here I'll go till 11. So I square is what? 4. So 4 plus 2, 6, 6 plus 2, 8, and 8 plus 2, 10. All of this I'll mark as 0 because these are multiples of 2 and 2 is a prime, so this can't be prime. Then I'll go to I equals to 3. P of I is 1, means it's a prime number. I square is 9. So I'll mark this as 0 because if this is prime, its multiple can't be prime. Then I'll go to I equals to 4, but P of I is 0. It is not 1, okay? So we'll not go inside the loop. Then we'll go to, then we'll not move forwards because outer for loop is I square less than 10 to the power 6. Here it will be I square less than equal to 11. So it will go only up till 3, okay? So here if you see 0, 1, 4, 6, 8, 9, 10, these are marked as zeros because these are not prime. 2, 3, 5, 7, and 11 are marked as 1 because these are prime. Once we do that, what we basically do is we calculate the sum of array elements. So we run a for loop and calculate the sum of the given array elements, okay? Now let's say that I is a prime number greater than equal to sum, okay? So for I equals to sum, because it is greater than equal to sum, I is less than equal to 10 to the power 6, I plus plus, okay? So as soon as we encounter the first number which is prime, if P of I equals to 1, why first number? Because we want to find the smallest integer which can be added to the array to make it a prime number. So if P of I equals to 1, then what is the number which I need to add to the array? It is I minus sum, okay? So this will be the smallest number which I need to return such that if P of I is the smallest number greater than equal to sum, which is a prime number, then I minus sum is the new element which I need to add to the array. So I will return this. What will be the time complexity? This will be 10 to the power 6 log 10 to the power 6, and this will be 10 to the power 6 size for loop, okay? So ultimately it will be 10 to the power 6 log 10 to the power 6 base 2, and this will be time complexity. And what would be auxiliary space? It will be big O of 10 to the power 6 because I am taking one array of size 10 to the power 6. Now let's look at its actual implementation. So if we look at the actual implementation, so I have taken one P array of size 10 to the power 6 plus 1 in which I will mark the numbers as prime. In the input we are given array and n. I have first of all marked all the numbers as prime. Then I have said 0 and 1 are not prime. And then this is the for loop which I said. So accordingly, after I come out of these for loops, all the numbers will be marked as prime or not primes, okay? Then I have taken one variable sum in which I will store the sum of all the array elements, and then I will start from the sum and go up till 10 to the power 6 to find the nearest prime number greater than equal to sum. Whenever I find that prime number, the new number which I need to add to the array is I minus sum, and I will return it, okay? Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you understood the solution completely. Thank you.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem Smith number. So, now, let us discuss what this problem is all about. This problem is asking us to tell us that if a number is a Smith number or not. And when a number would be Smith number? A number would be a Smith number when it is a composite number. Okay, what do you mean by composite number? All the non-prime numbers are composite numbers. It has more factors than 2. Okay, and the sum of the digits of the given number should be equal to the sum of the digits of the prime factors. Okay, this is what is asked. Now, let us first understand what is asked. Given a number n, okay, and the n value is still 10 to the power 5, a small thing to notice, but yes, it should be noticed. Now, moving forward, we first need to check, like, to confirm if it is a Smith number or not. We first need to check if it is a composite number or not. That is checking for prime, and we already know an algorithm where we can check a number if it is prime number or not in square root of n. Square root of n, this is what we can do. Now, sum of the digits of the number n. Sum of the digits, taking out sum of the digits is also very easy. How? Like, let's say we have 386. So to take out the last digit, what we would do is 386 divided by 10, which is equals to 6. Then 386, we would say that at this point, we would divide it by 10, the integer division. After doing the integer division, it would be left with 38. Now again modulo 10, which would again give me 8. Again, doing the integer division by 10, we would be getting 3. Again modulo 10, which is equals to 3. Again divided by 3, which is equals to 0. So we can see that by doing 2 operation each time multiplied by the number of digits, we can get the sum of the digits. And the value can at max be 10 to the power 5. So we need to number of operation needed would be 6 elements at max, multiplied by 2, because 1 for bringing out the modulo, 1 for dividing it. So in 12 operation, we can find out the sum of the digits. Okay, so sum of the digits is also done. Now, finding out the prime factors. Finding out the prime factors is also very easy. How? Let's say we have something like 15. So what we can do is we can start working from 2. 2 can divide 15. No. 3 can divide 15. Yes. So we would divide 15 by 3, which would be equal to 5. And then 4 can divide 15. No. 5 can divide 15. Yes. So again, we would divide. This is how all the numbers which can divide the number, we would keep dividing it, and they would contribute as the prime factors, and that would be done. And this is again, taking out the prime factors is again square root of n. And sum of the digits is the same. So now let us just implement what? A function known as isPrime, which would just check if a number is a prime or not. Let's just implement sum of the digits, which would just bring out the sum of the digits. The third part is that we would just build up or to find out all the prime factors, and that is done. So finding out prime factors, checking if a number is prime or not, and sum of the digits. These are the 3 functions you would require. That would be done. Now let's just move forward to the implementation. So now I would just implement int sum of the digits and int n. So now I would say int initially the sum is equals to 0, as I have shown you. While n is greater than 0, we would keep doing it. So sum plus equals to n modulo 10, and then n is equal to n divided by 10, writing out the shorthand of it. Now the very next step is to write a function which would check if it is a prime number or not. So we would just say bool is prime, and we would give it a number n. We would handle the corner cases, that if n is less than equal to 1, if n is less than equal to 1, return false. Now we would start moving from I is equals to 2, I is less than equal to square root of n, and I plus plus. At this point, we would say if n modulo I, if it is equal to 0, like if we are able to find any number which can divide the given number other than himself or 1, then we would say it is a false. If till the end we were not able to find a flaw, we would simply say return 0, return true, that it is a prime number. Now the very next step is finding out the sum of the digits of the prime factor. So we would say int SOD of what? Prime factors. Okay, and we would just give it a value n. And then we would start the sum. Int sum is equals to 0. Done. So now we would start doing it. For int I is equals to 2, I is less than equal to square root of the value n, and then I plus plus, and then we would say while n modulo I, if it is equal to 0, then we would say sum plus equals to sum of the digits of this particular factor. Okay, and then keep dividing the numbers, like n divided by equal to I. N is equals to n divided by I. Okay, at the end, okay, if the given number is greater than 1, okay, then sum plus equals to sum of the digits of the given number n. Okay, it's done. Okay, so we have bull is prime, sum of the prime factors, and then this thing. Now let us code the last statement. But if it is a prime value, if it is a prime value, then it is not possible because the first condition is void. Else we would simply return that if sum of the digits of the given value, if it is equal to sum of the digits of the prime factor, sum of the digits of the prime factor, then return accordingly. If this would return true, the function would return true. If this would return false, the function would return false. Okay, seems correct for the sample test cases. Now let us see for the complete test cases. Okay, seems an issue with the code. I didn't really return the sum. I just saw it at this point. If int sum plus, so I didn't return the sum at any point. Yep, so I should return the sum. Let us just see again. And yes, it's done. So I just forgot the return thing. So I just saw it when I was just going through this in just a sec. The time complexity is square root of n. So that's it from my side. Thank you, everyone. Hi, and welcome to Geeks for Geeks. Today, let us discuss the problem subarray with the zero sum. So now let's talk about the intuition of this problem. The solution of this problem is not intuitive. Okay, let me just tell you. If I don't write out something, you won't really be, it would be intuitive enough. So if this intuition was not coming into picture, that's absolutely fine because the solution is not intuitive, but it is an easy problem in general. So let's talk about this problem. It is told that we need a subarray with the zero sum. Okay, so at this point, if it is asked that we have something like 4, 2, -3, 1, and 6. If you observe that if you add up these three, then this would just sum up to the subarray 0. So now the only thing to notice here is that, okay, the first brute force is that we would be taking out each subarray as having the value. If any of the subarray equals to the value 0, then it would be the answer. An optimized approach would be that we would write the prefix sum. So prefix sum is the prerequisite here. Okay, so if I write the prefix sum of this, the very first number would be, we don't have any element up till this point, so we have 4. Then we have 4 added to 2, that is equals to 6. 6 added to 3 would be equal to 3. 3 plus 1 is equals to 4, and 4 plus 6 is equals to 10. And the point where we have a subarray with zero sum is this one. Notice something here. Okay, let's just see more. So now let us say that we have an array something like 5, 3, 2, -1 and -4, and then 6 and 3. So if I write the prefix sum of it, so now if you observe, the very first value is 5. 5 added to 3 is equals to 8. 8 plus 2 is equals to 10. 10 minus 1 is equals to 9. 9 minus 4 is equals to 5. And 5 plus 6 is equals to 11. 11 plus 3 is equals to 14. Okay. So now, if you observe that this is the segment which contains the prefix sum with the zero sum. If you observe in both of this, you would see a strange thing, that this number is this number and this number is this number. Why is this? Because if what is prefix sum? Prefix sum is sum till this point. Sum till this point. So let's say if the sum till this point is x and this whole value, this whole sum is, let's say, 0. Whole value is 0. Then at this point the sum would be x, because x plus 0. Up till this point it was x. Up till this point the value was x. And then we add 0 to it. So in the end it would be x only, because x plus 0 is equals to x only. So I can safely say that while doing the prefix sum, if I am seeing the same value again, then that value is subarray with zero sum. Because let's say the idea is very simple. Let's say I'm a human being. Okay, let's say I started going to the gym. Okay, this is me. I started going to the gym and my weight was 57 kgs. Okay, I went to a marriage. In my uncle's marriage, I ate something out of it. I gained 1 kg, and then again I gained 2 kg. Then I came and I started running, and in the end, so my net would be that I'm again standing at 57 kg. Why? Because the contribution of this is 0. So if I'm seeing the same weight of mine after some days, like let's say this is 1st of December, which was my birthday, so everyone forgot to wish. So this is, let's say, 5th of December. Okay, so I would say that the contribution to 1 to 4th, the contribution of weight from 1 to 4th is 0, because my weight remained constant. So just we are using this intuition that the value would be constant. Okay, so I would just say I saw here this, I saw here this. So the contribution of all these days was nothing but 0, neither negative nor positive. And that's it, my friend. That would be done. So I need to remember if I have seen that value before or not. Okay. So in programming, whenever we need to remember that we have seen some value before or not, there are two steps to it. Either you just trace back and see if this value was present. The very next step is you start to memorize. Like I can just keep a feed in my mind that yes, I have seen this value. And that's it. We would just hash out all the prefix sum values and that would be done. So I would be making this as just a, because I'm a very lazy person. So I would be using here as unordered map to hash the values. Unordered map of int comma boolean to just tell me if this I have seen of this value before or not. Now I would say int sum is equals to 0. Okay. Now we would start on the iteration of this. So for auto e dash a, this is just, so I would just write the general syntax, not this. Int I is equals to 0, I is less than n, and I plus plus. I would first add it to a of I, and I would say if MP of sum is before hashing only, I see as a true value. Like I have seen up this value before, I would return true. If till the end we were not able to find any repetitive values, I would return false. But there is a small flaw in this, that is this test case. The test case such as 3 and -3. The values, the prefix sum values would be 3 and then again 0. But we have not seen before. But see, this is a zero sum subarray. So if we are by chance seeing any 0, that if at any point sum is equals to 0 or MP of sum is equals to true, then we would return true. At the end, we would just also hash the values. This was a small addition for this small corner case. Now I'll just compare and see how many errors are we making. So the value seems correct. Now let us try to submit this and see if we can get an EC or not. So that's it for today. Thank you and have a nice day.
Hello everyone, we are back here with the problem of the day. The problem that we have today is maximum sum subarray of size k. Let's read the problem. Given an array of integers, ARR, of size n and a number k, return the maximum sum of a subarray of size k. And a note is given, a subarray is a contiguous part of any given array. Alright, now what are we receiving here? Okay, the task is, we don't have to read or print anything. The task is to complete this function. We are getting integer k, ARR the array, and n, which is the size of the array. Okay, fine. The expected time complexity is on and the space is o1. Let's see the test cases and try to understand the problem in a better way. So here is the first sample test case. As you can see, n is 4, k is 2, and this array of 4 size is given. Now what do we have to do? We have to take the subarrays of size 2, we have to find the sum of it, and we have to return the maximum sum that we can obtain. So if we talk about this array, and we know that the size is 2, the first subarray could be this, correct? 100 and 200. The sum of this will be 300. Then the next subarray could be 200 and 300, correct? The sum of this subarray is going to be 500. Eventually, there will be one more subarray of 2 size, which is 300 and 400. Sum will be 700. What is greatest of them all? 700, right? Thus 700 is the answer. Simple. Now you might see one thing in both of the test cases, that the array is sorted, but it is nowhere mentioned in our question that the array will be sorted. So it is just a coincidence. We don't have to consider that as a particular parameter. Now let's talk about this sample test case. This time what you are given is, you are given the size as 4. That means we have to take the chunk of array which is of size 4. Now the whole array is actually of size 4 only. That means we can make total of all, and all will be summing up to 1000. That will be the answer, correct? So actually, if we just even think of the brute force approach, the very basic approach of this question, that can lend us the answer, right? Which is finding all the substrings and then finding out keeping the maximum one. Let's try to think of that in a better way. Okay, I've taken this array now, and let's say we have k equals 3. That means we have to take subarrays of size 3. What I can do is, first of all, I have to check this, right? I have to check the first chunk. So I'll just maintain a sum of these first 3. I'll say I have my sum, and it is actually 3 plus 5 plus 2. That will be your 10. Okay, I have my sum 10. This is my current sum. And I will also maintain one variable, max sum. This will be keeping the track of the maximum value that we have seen so far. So far, we only have seen 10. That means 10 is our maximum till here. Now what we have to do, we have to keep on looking for, further on subarrays, and we need to find out the sum of it. Now, if we go on taking every subarray and then finding out the sum of every subarray separately, it is going to take more time. But rather what we can do is, we can just think of it as a window, right? Think of it as a window of k size. Here it is 3. So once we are going to, move this window ahead, what will happen? This window will now be here from 5 till 7. Let me write down the indices like this, right? So initially my window was beginning from 0 and it was ending at 2. Now I have to shift it one step ahead. It will be beginning from 1 and ending at 3. Now what has happened? The sum of the previous window was 10, correct? Now the next window, the shift that I have made is including 7 and excluding 3. So whatsoever was my current sum, what I'll do is, from my current sum, I will add up the new element, I'll add up ARR 3 and I will subtract this value, ARR 0. Correct? Now, when we are going to do this again, we are going to move it here. Well, if we, let me just calculate this as well. It was 10 already. We added 7. It became 17. We subtracted 3. It became 14. So our current sum after this is 14. Maximum will be updated to 14 as well. Correct? Now again, window will move here. Now we have 2, 7 and 1. That means we were having 14. I included 1. It became 15. We excluded 5. It became 10 again. Now again the sum will be 10. Max won't be updated. Correct? Now what do we have to do? Simply, we need to perform this till the end of the array, right? Till we reach the 8th element here. Now one thing that you have to keep in mind is, we have to generate a formula for this, a little formula. We were having I as a variable which was helping us traverse this array. So if I am including the next element as ARRI, what do I have to minus? I have to minus ARRI minus kth element, because k is 3. So when my I, let's say when my I is 4, that means I'm including 4. What do I have to subtract? ARR 4 will be included. ARR 4 minus 3, that means 1. 1 will be excluded, right? So this will be the formula. We will keep on doing that and we will keep on maintaining a current sum and we will track the maximum one from the iteration. Eventually we are going to return the maximum sum. Okay, so here is the code for the same. Just we have discussed. I'll first create my result, or you can say maximum. It will be keeping the track of maximum. I have just calculated the first chunk. That means this was my whole array. I calculated the first k window. It is stored in the result. And currently, because we do not have anything else, we are going to consider that as a current sum and the maximum both. Then we are going to iterate through the array. What we are going to do, we are going to begin from k. K is this element, right? It is beginning from 0. K is this. The size of the subarray is from 0 to k minus 1. We are going to begin from k, we'll go till n. We are going to begin from here, we'll go till n. Actually n minus 1 if we are using range of Python, right? We are doing the same thing. Every time we are increasing our I, I'm including that element and I'm subtracting the previous element. I'll take one step, I'll include one more element and I'll exclude one element from the previous, right? We have understood that. Then I'm just keeping the track of maximum in the result. Eventually I'm returning the result, right? Quite simple. Now the complexity it might take is obviously on. We are just traversing the array for one time and we are not performing any other operation. So just let's try to run this code against all the test cases. Okay, so here is the code. Let's compile it. All right, it is getting compiled. It is giving us the right answer. Trying to submit that. Okay, so it has passed all the test cases. So the problem was quite simple and I hope that you have understood it well. Do comment down below if you like the approach and share the video with your friends. Thanks. Keep coding.
So hello and welcome everyone. I am Jadal Sania, and in this video, we are going to solve the problem of the day, that is gold mine problem. So this problem is comes under the difficulty level medium, and if you do a little bit of brainstorming on how to solve this question, it is not going to be that much difficult for you guys. So I am sitting over here so that you guys can understand the best optimal approach possible for this question. So let's hit the target of 50 likes in this video, and without any delay, let's start the video. So first of all, I will be reading down the problem statement, and then we'll be having a look at the examples given in the question. So first of all, what is the question? So given a gold mine called M of n cross m dimension, each field in this mine contains a positive integer, which is the amount of gold in tons. Okay, so each and every cell in the matrix contains some integer that denotes the amount of gold in tons, and initially the miner can start from any row in the first column. Okay, so the restriction of the starting point is that you can start from the first column and any row. You can pick any of the cell in the first column from any row. So from a given cell, the miner can move in three different directions. Okay, so it can move to the cell diagonally up towards the right, so diagonal side, and to the right hand side, and to the cell diagonally downward towards the right. So there are only three different directions from each and every cell. You can move in this direction, and in the rightwards direction. So you have to find out the maximum amount of gold which can be collected until he can no longer move. So you have to find out that like what is the most amount of gold that can be collected by the miner if he starts from any of these cell in the first column. So now what I'll be doing, let's try to understand with the help of the test case which has been mentioned over here, so we can have a better understanding. So here is the entire test case given to us. So what is the test case? So n is equal to 3 and m is equal to 3. So the dimension of the given matrix will be n cross m, and n and m over here, both of them are same. So we can imagine a matrix of size 3 cross 3, and the elements will be 1 3 3 2 1 4 and 0 6 4. These are the values present inside each and every cell. So now we have to find out that what is the maximum amount of gold he can collect if he starts from any of the cell in the first column. So I have three different values, right? I can either start from this 1, I can start from this 2, or I can start from this 0. So one by one, let's try to tackle each and every element in the first column, and let's try to find out that what will be the best amount of gold we can collect from each and every cell. So from 1, I have two different options. But before understanding that how to find out the values, we need to know which different directions we can. So you can move in this direction, you can move in the rightwards direction, and you can move in the downwards rightwards direction. So basically, if a cell is present over here, you can move towards that cell. If a cell is present in the right hand side of this cell, and this is going to be your starting cell, let's say you are currently standing at this cell, you can move in this three different directions. And if there is a cell present over here in the top right hand side, then you can move in that cell as well. So there are three different directions. I hope nothing makes like difficult to understand about direction. So now let's say to find out the values, like let's say from this one I can move in this direction, I can move in this direction, I can move in this direction, right? So what I did, as I know I have to find out the maximum amount of gold which I can collect. So what I'll be doing, I only have two possible direction. One of the direction goes out of the matrix, so I can either go to this 3 or this one. And as I know I need to find out maximum one, so what I'll be doing, I'll be choosing the maximum one. So from here, from this one, I'll be traveling to this 3. And again from here I can have two different directions, but basically 2 are valid, and out of 3, so I can move in this 2 direction. And now again I'll be greedy, and I'll be selecting this 4. So now from here I again have 3 different direction. No, actually I have 3 different direction, but none of the direction is inside the matrix. So this is the entire way, and in this path, how many cells and which cells were encountered. Let's try to find out the value. So that would be 1 plus 3 plus 4. 1 plus 3 plus 4, that is going to be 7 in this scenario. So now this is one of the possible path, and now let's try to find out, let's say if I am selecting a different path, then what is the value which I'll be getting from 1. So now let's say if I start in this direction, so from this 1 I'll be going to this one, and now from 1 again I have 3 different possibilities. I can move any of the 1. So what I'll be doing, I'll be going with the major one. So that would be with this 4. That would be 1 plus 1 plus 4, that is going to be 5. And I don't think you can do better than this 5 and 7. So for this first cell of the first column, you can do better, means like you can get the maximum answer as 7. So for this one, it will be 7. And now let's try to find out the answer for the other ones. So now let's try to find out the answer for this 2. So from this, I can move in 3 different directions, but I'll be moving in the most optimal one. So I'll be selecting this 6. So from this one, from this 2, I will be moving in this direction, and from 6, I can move in 2 different directions. And both of them are having the same value, right? So it does not matter whichever 4 you are selecting. So I'll be moving in this direction. So that would be giving me 2 plus 6 plus 4, and that comes out to be 12. So for this, I got one of the answer, that is 12, and I think you cannot do better than 12 for this 2. So now let's try to understand, let's try to find out the maximum answer for the last cell. Let's try to see. And now for the last one, what do you think? What can be done? So let's say for this 0, I have 3 different directions, but only 2 of them are valid. So I'll be moving in this direction 6, and from 6, I have 2 directions valid, and both of them are having the same value. So that would be 0 plus 6 plus 4, that comes out to be 10. And for this one, I cannot do better than 10. Right, so for each and every cell of the first column, I found different answers, and from this one, what do you think, which is the maximum one? Obviously this 12. So the output for this test case comes out to be 12. Okay, so this is the entire process, and I hope you understood that how to find the answer, and you can check it in the question as well inside the problem statement, that for the example number 1, the output is equal to 12. So the main reason behind showing you each and every step was that in the upcoming part of the video, you will be understanding that what actually is the process, how we can solve this question. Okay, so now let's try to think a little bit, and like let's try to find out what can be the solution of this one. So let's try to find out any of the approach number 1. So now let's say I have a 3 cross 3 size matrix. So what I can do, can I explore each and every possible path and try to find out the maximum answer? Yes, you can do that, but the time complexity of that approach will be very much huge. It will be something exponential or near about to exponential. Okay, so what I'll be doing, if you try to focus on that approach, let's say from this 0, from this cell I'm moving in this direction, and from this I'm moving in this direction. So now let's say if you took a different path, and if you were traveling from this cell, you started from this cell, this one. So from this one, what you can do, you can move in this direction. So again, you will be encountering this cell for which the maximum path you might have already explored. And from here, you might be again going in this direction. So you are following the same path again and again. And the time complexity of this will be near about exponential, and this is not the feasible approach. Okay, and if you try to follow this approach, the brute force, that is trying out each and every possibility, your approach is going to fail for sure. So now what can be the optimal approach? What can you do in order to avoid the repetition of the paths? So the repetition of the paths can be avoided with the help of memoization. So basically, if you focus on what the question is trying to say, the question is trying to say that you have to find out the maximum amount of gold which he can collect, right? Basically, you have to find out the maximum sum of the numbers in that path. So now, if you focus on that, no, as I mentioned that there are 2 different ways to follow a different path. One of the path is this one, and this path can be followed by someone in this manner as well, right? So if you have already understood what I'm trying to say, let's say for any of the cell inside the matrix, if you have found out that what can be the maximum amount of gold that can be collected starting from that cell, then you can store that value in some table in some different matrix, and that matrix can be called the memoized matrix. Basically, you will be taking the help of the other matrix. So let me show you. Let me just copy the entire test case, that is 133, 214 and 064. 133, 214 and 064. Okay, so now for this matrix, what I will be doing, I will not be exploring each and every path. I will be simply exploring each and every cell only once, so that I don't do repeated work. I don't explore the repeated path. So now let's try to understand what I'm trying to say. Let's say this is the matrix, and this matrix goes by the name DP. Basically, for each and every cell, I'll be storing that from this cell, what is the maximum amount of gold that you can find, right? So that values will be stored and initialized this entire DP matrix with -1. So -1, that indicates that this path, that this cell has not been explored yet. So now let's try to focus more on what I'm doing. Each and every steps are very much important. So you will be understanding, and it is possible that after understanding the entire approach, you guys might be able to write down the entire approach on your own, just looking at these steps. Okay, so pay proper attention right now. So now let's say if I'm starting with the cell number 1 from this cell. So from this cell, I have two different possible paths. I can go in this rightwards direction, or I can go in downwards right direction. Right, so I have two different paths, right? So for each and every cell, I have, let's say, three different possibilities. I can go in upper, that is upper right direction, in the right direction, or I can go in the lower right direction. Three different values will be possible for each and every cell. So basically, what is the maximum amount of gold that any of the cell can carry? Gold that any of the cell can get carry is nothing but the maximum of the value which you have found from the upper right hand side, and the lower right hand side. Okay, are you guys able to understand this formula? That basically, what is the maximum amount of gold that I can get from all these three different cells where I can travel? And I'll take that maximum and just add whatever gold is present at the current cell. Okay, so now I will be exploring each and every side. I will be going in the upper right, rightward direction, and lower right. Okay, so three different function calls will be made. A DFS function, a DFS call is required. I'll be using DFS, depth first search, in order to traverse the entire matrix. Obviously, there are three different ways, like only two different ways to travel the graph or something, right? So basically BFS or DFS. And here DFS is more suitable because you don't need to work radially. If you are supposed to work radially, then that means you can use breadth first search. But here you need to focus on a particular path. So that's the reason I'm using DFS. Now I'll be applying DFS from each and every cell of the first column. And let's say I made a function call to the first cell of the first column. And now I have two different paths. That is row right hand side and lower right are the valid path. And I cannot move in this direction, upper right hand direction. So I'll make a function call to both of them. So in the rightward direction, if I move in this rightwards direction, I'll be getting 3. So from 3, where can I move? I can move in the rightwards direction. I can move in the lower right. So I have this 3 and 4. So basically, I'll explore both of them. I'll explore 3 and 4. So let's say if I move to this 3, I know that after 3, I cannot move anywhere else. So what is the amount of gold that you can collect from this last 3? That is equivalent to 3. So I'll add and pass that value to this 3 over this function call over here. Right? So from this 3, we got 3. And now from this 4, I will be again calling to this, making a function call to this 4. And from this 4, I'll check whether I can move forward or not. So from 4 as well, I cannot move anywhere else. So this 4 will also return the value that from this cell, you cannot move forward. And currently, my position has 4 tons of gold. So 4 will return 4, and you'll be getting two different answers at this function call. You'll be getting 3 and 4. Right? So basically, you got two different answers. That is from the rightward cell and from the downwards right cell. 3 and 4. Choose the maximum one. Which is maximum between 3 and 4? Which is maximum between this and this? I can say obviously 4. So for this cell, you have to just select the maximum that you got from the right and the lower right. So I got 4, maximum of 3 and 4. That is right and lower right. 3 and 4 came out to be 4. So adding 4 to the whatever amount of gold is present at that cell. So I can see 3 tons of gold is already present. So that becomes 7. So whenever the entire thing, that exploration of all the different paths is completed, so you will be finding out the maximum gold that you can collect from that XYZ cell. So from this cell, you can collect 7 tons of gold. So make an entry inside the DP array that from this cell, maximum 7 tons of gold can be collected. Okay, so -1 will be replaced by 7. Similarly, I have also completed the answer for these two cells, right? I got the answer as 3 and 4. So I'll make an updation over here. That is, this is 3 and 4. This is the maximum gold you can get from that cell. Okay, so basically, what is the use case? What is the use case about this? You will be understanding just in a few minutes. So now let me just clear out this drawing a little bit. Okay, so now we have explored this path. We have explored this direction, the rightwards direction of 1. So now let's try to explore the other direction, that is in the lower right. So in the lower right, this is the cell, that is 1 is the cell number. So now from this 1, before exploring or making DFS further call, you will be checking inside the DP matrix whether that cell value is -1 or it is not -1. If it is -1, then that means that cell needs to be explored again. Like basically the exploration is not done at least once, so you'll be exploring that cell as well. So now I can see -1, so I'll be exploring all the paths, so I can move in the upwards direction, downwards, and the rightwards direction. So 3 different directions are possible for this one, right? All the 3 different directions are possible. Let's say if I move in the upright direction, from 1 in the upright direction, I can see 3. So I'll be reaching over here. So as soon as I reach this 3, I will be checking whether I have already found the answer for this 3 for this cell or not. So I'll be checking the DP array and I can see it is not -1. So if it is not -1, then that means I have already explored the further paths passing through this tree. So I'll just fetch the value from the DP array. So from this DP array, I will be getting 3 for this upright direction, that is upright direction. Now from 1, I'll be moving in the rightwards direction. Okay, so I will not make further DFS call for this 3. So now I'll be backtracking again and I'll be exploring the rightwards direction from 1. So from 1, this is the rightwards direction. Again, I'll be checking inside the DP array whether the value for this cell is -1 or not. It is not -1, it is 4. So from DP array, I will fetch that value. So this 4 will return what? It will return 4 in this scenario. That 4 is the maximum amount of gold that can be collected from that XYZ cell. Now from this one, only one direction is left to explore, and this is the direction. So I'll explore this direction because I can see -1 is present, right? So this is 4 and this is the lower right direction, and I cannot see anywhere else I can move from this 4. So for this 4, exploration is not possible in any of the direction. So I'll update that value that for this 4, only 4 is the amount of gold that can be collected. And now this 4 will return 4 to this one. Okay, so now I got 3 different values, and what will be the maximum one? So for this one, I got maximum of upper right, rightwards, and lower right. So for lower right, I got 4, for the rightwards direction 4, and for the upper right, I got 3. What is the maximum one? 4 is the maximum one. And what is the current gold that cell is holding? It is holding 1. So what is the total maximum gold that you can collect from that cell? It is 5. So inside DP matrix, just update that value. I'll update it to 5. So now you can observe, you might be able to observe that whenever you again come to the cell number 1 in further DFS call, you will not explore all the paths because you have already found the maximum answer, and you will just fetch that value which you have stored inside the DP array. And this will reduce a lot of tasks. It will reduce the entire time complexity because here you will be exploring each and every cell only once. None of the cell will be recalculated any of the time. They will be calculated only once. So the overall time complexity becomes total number of cells inside the matrix. So what is the number of cells present? N cross M. So the overall time complexity of this approach comes out to the order of N cross M. And what about the space complexity? The space complexity depends upon the DP array, and DP array takes order of N into M size. So this is the space and this is the time complexity, right? So this question was not that difficult. Few of the concept memorization plus DFS is sufficient, and it is sufficient to get the solution accepted. Right. So now let's have a look at the implementation part of this algorithm, and let's solve this question. So this is the implementation part of this question, and I have implemented this entire thing in Java, but the same can be implemented in other languages. Just take the reference of what I have explained few minutes back. So now let's start. This is the max gold method, and we have to write down our logic inside this method. N and M are the dimensions of the matrix, and I have changed the name of the matrix given to us. 2D array, I have changed it to matrix. So I have created a new DP array that will be helpful for my memorization process, and I have initialized the entire DP array with -1 because I need to make sure whether that value or the cell is visited or not. So -1 is a good indicator in this scenario, right? And now I have used one more variable that will store my answer. Something is required to store the answer, no, right? And I know -1 is not going to be the answer because I'll be getting positive values, and how positive values you can observe inside the constraint that each and every cell will be having positive values. So I initialized it to -1. Now I have started an iteration over each and every cell of the first column one by one, and I'm making a DFS call. You can observe I comma 0, basically column number 0, ith row, making a DFS call. And whatever is the value, maximum value for that cell, whatever is the maximum amount of gold I can collect for that cell, I'm storing it inside temporary variable, and I'm just comparing it with the overall answer and what can be the maximum answer. Right? So now let's have a look at the DFS, a basic DFS function call. Okay. So what are the arguments? So argument is the matrix. We require the matrix, the current cell number I comma j, and the DP array in order to just check the memoization. So now I have just fetched the n cross m, basically the dimension of the matrix, and I have used a temporary variable. You will understand why I have used temporary variable. So now what I'll be doing, so I have three different directions, right? You agree? So top right diagonal, and basically like right side and bottom right diagonal, right? So three different directions are possible. So I'm checking I minus 1 and j plus 1. So the dimension, if I'm currently standing at I comma j, let me just show you what is the position. So now let's say currently you are standing at I comma j, and I comma j, this is your I comma j. Now what is the, how to reach this cell? So basically if you subtract the value of row by 1, because you know the row number is being reduced, and if you increase the value of column number, you know the column has been increased by 1, so you'll be reaching this one. So that is I minus 1 and j plus 1. You need to verify whether the value of I minus 1 and j plus 1 remains inside the matrix or not, right? So now let's say to find out, if I move in the rightwards direction, you know the row number remains as it is and the column number is increased by 1. Similarly for this one, what will be the scenario? I know that row has been increased by 1, and similarly the column has increased by 1, so that would be j plus 1. So these are the three different directions in which I can move. Now let's get back to the coding part, and now you will be able to understand what is this I minus 1 and j plus 1. Okay, so I need to check whether the value remains in the matrix or not. Okay, and I'll be checking if the cell has been already found. Basically, if it has been already explored, then value will be minus 1 inside the DB matrix, and then I'll be just comparing the value of that cell with the temporary variable. I need the maximum from upper right, lower right, and the rightwards. Okay, so this will be compared, and now I'm just checking the right hand side. Okay, so for right hand side, I know just there will be increase in the column number only. So now j plus 1 will be checked, and if that cell is already explored, so just fetch the value and compare it with the temporary variable. Else I'll be making a function call, and I'll be just comparing the value of temp with the value written by the DFS call. Okay, so now the same thing will be done with the bottom right, and at the end, whatever is the value of the temp, I'll be just adding the current matrix, that is basically I comma jth cell value with the temporary variable, and that will be updated inside my dpi comma j, and I'll be returning dpi comma j. Right? So this is the entire DFS with some memoization, and now let's try to just completely submit this code and let's see the acceptance. And we can see that the problem has been successfully submitted. And as I mentioned, the time and space complexity remains order of n into m, and this is justifying the expected time and space complexity, right? So this was all about the gold mine problem, a basic memoization with some graph concept like DFS with matrices, right? So that was it for in this video. I hope you really enjoyed this video, and if you really enjoyed this solution, do hit the like button and comment down your solution in the comment section below. So thank you for watching, and I will be seeing you in the next video. Till then, bye-bye.
Hello everyone, my name is Karan Masru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is consecutive ones not allowed. First of all, let us start by understanding the question. What does question say? Given a positive integer n, count all possible distinct binary strings of length n such that there are no consecutive ones. So we have been given length n, and we need to find how many binary strings, means strings containing zeros and ones are possible of length n such that there are no consecutive ones, means two ones should not be together. Okay, two ones, three ones, no, at least two ones should not be together. Okay, so even three ones are also consecutive ones. Output your answer modulo 10 to the power 9 plus 7. For example, if my length is 3, then there are 5 binary strings in which there are no two consecutive ones, that is 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0 and 1, 0, 1. For n equals to 2, it is 3. You don't have to print answer or take inputs. Complete the function count string which takes integer n as the input parameters and returns a single integer denoting the answer. The expected time complexity is big O of n and expected auxiliary space also big O of n, and the constraints are given here. So now if we think about solving this problem, then what can be the brute force approach? The brute force approach could be to just try and recursively generate all the possible strings, and whenever we get a string where there are two consecutive ones, we do not count that. Okay, so we generate all the strings in which there are no two consecutive ones and return the count of the number of generated strings. Now recursively, if we try and generate all the strings, if there are n number of positions, at every position there are two choices, either 0 or 1, right? So for all the n places there are two choices. So the total number of strings generated is 2 to the power n, right, which is exponential. So this will give us time limit exceeded, and we need to think of something more efficient. Okay, so now let's try and do one thing. Let's generate the number of strings in which there are no two consecutive ones for some small values of n, and let us see if we can get some pattern. Okay, so for n equals to 1, there will be two possible binary strings in which there are no two consecutive ones, that is 0 and 1. For n equals to 2, we have 0, 0, 0, 1 and 1, 0, right? There will be three possible binary strings because 1, 1 has two consecutive strings. For n equals to 3, we will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1 and 1, 0, 0. Okay, so there will be 5 such strings. Okay, for n equals to 4, we have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, right? So this many are possible: 1, 2, 3, 4, 5, 6, 7 and 8. So for n equals to 1, the answer is 2. For n equals to 2, the answer is 3. For n equals to 3, the answer is 5. And for n equals to 4, the answer is 8. Can we see some pattern here? For n equals to 3 onwards, number of values possible is nothing but the sum of previous two values. For n equals to 3, the answer is 5, which is nothing but 3 plus 2. For n equals to 4, answer is 8, which is nothing but 5 plus 3, and so on. You can observe. For n equals to 5, you will get 13 total possible strings. Okay, so how can we do this? We can simply say dp, we can take one dp table. What dynamic programming I am saying? Because your solutions to smaller problems are used. First of all, we are converting this recursion into the polynomial, and solutions to smaller problems are used to solve the bigger problem. So I will take one dp table of size n plus 1, and I will say dp1 is equals to 2, dp2 is equals to 3, and for I equals to 3 to n, dp of I is equals to dp of I minus 1 plus dp of I minus 2. Okay, and at the every step I will say modulo mod, right? Because we have been said that take modulo 10 to the power 9 plus 7. So I will calculate this dp table. What does it indicate? dp of I indicates number of possible binary strings of length I where there will be no two consecutive ones. And finally I will return what? dp of n, right? So now let's look at its actual implementation. So if we look at the actual implementation, so I have been given n in the input, and I have taken mod equals to 10 to the power 9 plus 7. I have taken one dp table. I have initialized these two base values, and for 3 onwards I have made this relation, and finally I have returned dp of n. What will be the time complexity? It will be big O of n because I am running a for loop of size n. What will be the auxiliary space? The auxiliary space occupied here will also be equal to big O of n. Why? Because I am taking a dp table of size n. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, my name is Karan Masru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is painting the fence. First of all, let us start by understanding the question. What does question say? Given a fence with n posts and k colors, find out the number of ways of painting the fence so that no more than 2 consecutive posts have the same color. So basically there are n posts and we want to color them. We have k different colors to color them. Now we want to color them such that no more than 2 consecutive posts can have the same color. So 2 consecutive posts can have same color. If no 2 consecutive posts have same color, that is also okay. But more than 2 consecutive posts like 3 posts, 4 posts, 5 posts, etc. cannot have the same color. Since the answer can be very large, return it modulo 10 to the power 9 plus 7. For example, if n is 3, there are 3 number of posts and k equals to 2. There are 2 colors. Okay, let's say green and white. So there are 6 ways. One is this, second, third, fourth, fifth and sixth. Here there are 2 consecutive colors which are of same color. Here there are no 2 consecutive posts which are of same color. But among this, there is no case in which there are more than 2 posts which have same color. Okay, so those cases are not there. Similarly, if n equals to 2 and k equals to 4, there are 16 ways. Since this is a function problem, you do not have to take input or print anything as it is already accomplished by the driver code. You just need to complete the function count ways that takes n and k as parameters and returns the number of ways in which the fence can be painted modulo 10 to the power 9 plus 7. So we need to print the answer modulo 10 to the power 9 plus 7 because the answer can be very large. The expected time complexity and auxiliary space is big O of n and the constraints are given here. So now if we think about solving the problem, then see what is given. There are n posts. Okay, there are n posts and we need to color them. For each post, we have k different colors with which we can color them. Okay, and the condition is that there should be no more than 2 consecutive posts which have same color. Okay, so if there are no consecutive posts with same color, that is fine. If there are 2 consecutive posts at some places with same color, that is fine. But more than 2 consecutive posts cannot have the same color. Okay, so how can we solve this? See, the most brute force method would be to use recursion and some logic. Okay, so let's say if I call a function f of n, so f of n comma k. Okay, f of n comma k, that the total number of colors which you can use is n k and the total number of posts which you want to color is k. Number of ways to color this function will return me number of ways to color n number of posts using k different colors such that more than 2 consecutive posts do not have the same color. So what I can say, see, either the nth post will have same color as n minus 1 or it will not have. If it does not have same color as n minus 1, then what will be the output? It will be f of n minus 1 comma k multiplied by k minus 1. Okay, why? Let's say this is the condition where nth post and n minus 1 post do not have the same color. They do not have the same color. Okay, so this is, let's say, my n minus 1th post and this is nth post. If they have different colors, so here one particular color out of k colors will be used. So here one color is used at n minus 1th position. So if they are different at the nth position, I have k minus 1 options. Why? Because if they are different, I cannot take this color. I can take any of the other color. Okay, and it will not harm my condition also because these two are different. So into k minus 1. So number of ways to color n post using k different colors such that the condition holds good is equal to number of ways to color n minus 1 post using k colors multiplied by k minus 1. Why? K minus 1 options are there to color the nth post. Or if the nth post and n minus 1th post have same color, if nth post and n minus 1 post have same color, let's say this is nth post and this is n minus 1th post, these two have same colors, then what I can say, this is 0, this is n minus 2th post. So these two are same. So here at both places I will place the same color, but it should not be the same color as that of n minus 2. Because if these two have same colors and it is same as this, then there will be 3 consecutive same colors, which is not allowed. So if I want to choose a color at both these places such that they both have the same color, I have k-1 options, because I cannot take the color which is at this position, other I can take anyone, right? And they both have same color, okay? So total there will be k-1 choices. Out of this k-1 choices, any color I can color at both this post. So I can say it is nothing but k-1 ways multiplied by f of n minus 2k, okay, and the sum of this. So what I can say, if I read this recursion, number of ways to color n post using k different colors such that my condition holds good is k-1 times number of ways to color n-1 post using k colors plus k-1 times into number of ways to color n-2 post using k colors. From where did k-1 and k-2 came? Is it clear? Now this recursion will go further. So this will be equal to k-1 into f of n-4 comma k and k-1 into f of n-3 comma k. Like here it was n-1 and n-2. For n-2 it will be n-4 and n-3. Here it will be k-1 times f of n-3 comma k plus the other call k-1 times f of n-2 comma k, right? And so on, the recursion will go on, right? And these two I will sum up and give it to parent. Here sum will come here and finally I'll get the answer. What will be the base case? The base case will be when we will reach 1, f of 1 comma k, this is equal to what? K. Because if there is only one post, I have k different ways to color it. So in the recursion, the base case would be f of 1 comma k is equals to k and f of 2 comma k is equals to k square. Okay, so in the recursion, when I'll come at the base case, I will return these values. Now why this is k square? Because if there are two posts, I can color this post with any color and I can also color this post with any color. Why? If they are different, well and good. If they are same, two consecutive colors same are allowed. So this is k square. Okay, so this recursion will go on. Now this is a recursive function and it will take exponential time to solve, right? So we need to think of something efficient. So we want to convert exponential into polynomial. So can we think of dynamic programming? Yes, if we get repeating sub problems. Okay, are the sub problems repeating? Means the same sub problem is solved again and again? Yes. Or it is called overlapping sub problems. How? You can see here f of n minus 3k, f of n minus 3k, f of n minus 2k, f of n minus 2k. These are the repeating sub problems. So I can solve this using dynamic programming. So now I want to convert it into a dynamic programming problem. So how can I do this? Let us solve it with bottom-up approach. So in bottom-up approach, first of all, I need to take a DP table which will store the states. So now see here k is constant, only n is changing. So I can take a DP table of size n plus 1 where DP of I will denote the number of ways to color I number of posts using k number of colors such that this condition holds good. Now I want to fill this table. So I will say DP1 is equals to k, DP2 is equals to k square, and then from I equals to 3 to n, from I equals to 3 to n, I can say dp of I is equals to, I need to relate it with smaller sub problems. F of n is equals to f of n minus 2 into k minus 1 plus f of n minus 1 into k minus 1, right? So here it will be dp of I equals to dp of I minus 1 plus dp of I minus 2 times k minus 1. Okay, so this will calculate all the remaining values. What does this say? If the ith post and I minus 1 post have different color, then at ith post I have k minus 1 choices multiplied by number of ways I can color the first I minus 1 post. If ith post and I minus 1 post have same colors, if it is different color, I have k minus 1 choices and this is the number of ways to color I minus 1 post. If I and I minus 1 post have same color, then they cannot be equal to I minus 2. So it is dp of I minus 2 multiplied by k minus 1 types of colors. The same which we understood the logic here. And after coming out of the for loop, I will finally return dp of n, that is number of ways to color n post using k different colors, such that the condition holds good. Now let's look at its actual implementation. So if we look at the actual implementation, so I have taken one dp of n plus 1 size table and I have taken mod as 10 to the power 9 plus 7. I have converted k into m. Why? Because see, here I was multiplying by k minus 1, but it was integer and I am storing my answer in long because I want to return it. So if I take this as integer, so this is long into integer will give me result in integer. And it might overflow and give me wrong answer because integer's capacity is less. So I have converted k to m, which is a long variable, and then I have proceeded further. So dp of 1 is m, dp of 2 is m square, and then from I equals to 3 to n, this is the formula, and finally I'll return dp of n. What is the time complexity? Is big O of n. Here I am using a for loop of size n. What is the auxiliary space? It is also big O of n because I am using one dp table of size n. Now let's submit this code. Okay, so let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, my name is Karan Masru. Welcome to the video. So in this video, we are going to look at the solution of the problem, that is reach nth point. First of all, let us start by understanding the question. What does question say? There are n points on the road. You can step ahead by 1 or 2 steps. If you start from point 0 and can only move from point I to point I plus 1 after taking a step of length 1, find the number of ways you can reach at point n. So basically there are n points on the road and you are currently on point 0, okay, and there are n points from 1 to n and you want to reach to point n. And in every step you can either take a step of size 1 or step of size 2. So total how many different ways are there to reach point n? That is asked in the question. For example, for n equals to 4, the number of output is 5. For n equals to 5, the number of ways is 8. You don't need to read or print anything. Your task is to complete the function nth point, which takes n as an input parameter and returns the total number of ways modulo 10 to the power 9 plus 7 to reach the nth point. The expected time complexity is big O of n and expected space complexity is also big O of n. So if we now think about solving this problem, so what it is basically trying to say is, let's say my n value is 4, okay, so it is trying to say that there are 4 points on the road, 1, 2, 3, 4, and you are currently at position number 0 and you want to reach to point number n, that is 4 in this case, and in every step you can either move by 1 step ahead or 2 steps ahead. So initially you are here, so you can either go here or either go here, okay. Now from here you can either go to 2 or either go to 3, because again you can take 2 steps from here, you can go to here or you can go to here, right? Now from 2 you can go to here or you can go to here, okay. So from here you can go to here or you can go to here, and from 3 you can come here or go to 5, but there is no 5. So how many ways are there to reach 4? Okay, so if we look here, so one way is what? 0 to 1, 1 to 2, 2 to 3 and 3 to 4. You take all steps of size 1. Another is 0 to 1, 1 to 2 and 2 to 4. The last step you take of size 2. Another is 0 to 1, 1 to 3 and 3 to 4. This step you take of size 2. Another is 0 to 2, 2 to 3 and 3 to 4. You take a step of size 2, then 1, 1. Another is you go from 0 to 2 and 2 to 4. You take 2 steps of size 2 each. So total there are 5 number of ways. So this is what it is asked in the question. So what can be the brute force approach? See, brute force approach can be just to recursively call all the possible ways, okay. So let's say I want, let's say I call a function n, which basically returns me number of ways to reach point n from point 0. Now you think in this way, what could have been the last step? Means let's say I want to reach 4. What could have been the last step? At every step I can either take a step of size 1 or size 2. So in all the possible ways, the last step could have been either from 3 to 4 or 2 to 4. Last step means I am at point number n. Now I can take a step of size 1 or a step of size 2. So either I could have come from 3 to 4 or from 2 to 4. You can see here 3 to 4, 2 to 4, 3 to 4, 3 to 4, 2 to 4. Right? So number of ways to reach n, I can say it is nothing but number of ways to reach n minus 1 plus number of ways to reach n minus 2. Because the number of ways I can reach n minus 1, from all those ways, I can take a step of size 1 and reach n, and the number of ways in which I can reach n minus 2, point n minus 2, from there I can take a step of size 2 and reach here. So number of ways to reach n is equal to number of ways to reach n minus 1 plus number of ways to reach n minus 2. Now number of ways to reach n minus 1 is number of ways to reach n minus 2 plus number of ways to reach n minus 3, right? And number of ways to reach n minus 2 is equals to number of ways to reach n minus 3 plus number of ways to reach n minus 4, right? And so on, it will keep on going. When will we stop? When the base case arrives, f of 0 will be equal to 1, and I can also say f of 1 equals to 1 because I am already at the 0th step. So there is one way, like just stay there, okay? You cannot say it is 0 way, and f of 1 is 1. In order to reach at point 1, there is only one way. You move from 0 to 1, right? So whenever you reach f of 0 or f of 1, you return 1, okay? And in this way, you will get f of n. But this will give you exponential time complexity because it is recurring, right? And this will give you time limit exceeded. So you need to think of something more efficient. Now the time limit in this brute force is exponential. We want to convert it into polynomial. So can we think of dynamic programming? If there are overlapping sub-problems, then we can think of dynamic programming. Are there any overlapping sub-problems? See here, I am calculating f of n minus 3. What is overlapping sub-problems? If you calculate the same sub-problem again and again, then they are said to be overlapping sub-problems. Here also f of n minus 3 is calculated. Here also f of n minus 3 is calculated. Here f of n minus 2 is calculated. Here also it is calculated. So these are overlapping. So I can think of dynamic programming. Let us think of bottom-up approach in dynamic programming. So let us take a table of dp and let's fill it. Now what will be the dimension of dp table? Here I am taking only one parameter in the recursion table. So I can take one dp table of size n plus 1, where dp of I will denote the number of ways to reach from point 0 to point I using either 1 or 2 steps every time. Right? Now I need to fill this. So first of all, I need to fill the base case. So I can say dp of 0 equals to dp of 1 equals to 1. There is only one way to reach point 1, right? Now, how can I fill the remaining elements? I can say for I equals to 2, I is less than equal to n, I plus plus dp of I is equals to what? F of n is equals to what? F of n minus 1 plus f of n minus 2. So I can say dp of I is equals to dp of I minus 1 plus dp of I minus 2. And at every step we have to take modulo mod. So I take modulo mod. Mod value is 10 to the power 9 plus 7. So all the dpi values will be calculated, and after coming out of the for loop, I can return dp of n, that is nothing but the number of ways to reach to point n from starting from point 0. What will be the time complexity of this? The time complexity of this will be big O of n, because there is only one for loop. What will be the auxiliary space? It will also be big O of n because I am taking a dp table of size n. Now let's look at its actual code. So if we look at the actual code, so I have taken one dp table, I have taken one I to iterate, I have taken the mod value dp of 0 equals to dp of 1 equals to 1, and for I equals to 2 to n, dp of I equals to dp of I minus 1 plus dp of I minus 2 modulo mod, and finally I'll return dp of n. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.
Hi and welcome to Geeks for Geeks. Today we would be discussing the problem string count. So before talking about this problem, let's have a quick review of another problem, that is string permutation, which would just help us to understand this problem better. So this was a prerequisite, but even though if you have not understood or something, I would suggest you that you solve up this problem after this problem. This is not a prerequisite because I would be covering the things that is needed. But that is a very good problem of a recursion, and it has appeared many times in an interview, and I would suggest that, highly recommend it that you solve. Let's come back to this problem. Let's say in this problem, you are told that you can only use 1A, 1B and 1C. Okay, and so what are the probable strings that you would have? So if you talk about the recursion tree, it would be something like this. When A is replaced with A, it would become A. When A is replaced with B, it would become this. When A is replaced with C, it would become this. Now if we talk about this, our second character, B is replaced with B, it is this. B is replaced with C, it is this. Then A is replaced with this is this. And A is replaced with C, this is this. And then we have A replaced with A and A replaced with B, that is this. This is how we have all the permutation of the given string. So how many permutations do we really have? Okay, we have the length of the string is 3. Okay, let's just write it here. The length of the string is 3 and the number of strings that is produced using this is 6, which is nothing but 3 factorial, which is 2 multiplied by 3, which is equals to 6. This gives us a glimpse that yes, something like this is needed. Okay, just keep this in your mind. This would come into picture. Okay, now let's understand this given problem. In this given problem, you are told that how many strings you can make by using 1B and 2C, and it is at most. At most means what? Maximum. Okay, remember it. We can use 0B, you can use 1B. 2C, that means we can use 0C, 1C and 2C, and rest all places would be filled with A. Here comes a concept of multinomial coefficient. Okay, if you have not learned of this topic, let me teach you this topic. So if something is made up of distinct elements, then we have something known as permutation, and we have something like n factorial. If there are n elements and we need to find out how many possible permutations are there, that is n factorial. But let's say here we have something known as the length is, let's say the length is n is equals to 3. Let's just write it down. N is equals to 3. At this point, let's say I want to use just 1B and rest all C, 2C. So if 1B is used, so if there are 3 positions, and here if I keep 1, the remaining 2 positions are A. That is why I am saying that I can use 1B and 2 A's. So it would look something like this, that 3 factorial divided by 1 factorial multiplied by 2 factorial. Okay, this is the binomial coefficient thing. Let's understand this by using a formula. So if, let's say, now instead of A, B, C, let's say we just have A, B, B. Okay, then the number of permutations of A, B, B is how much? Let's just understand this by using this. Replacing A with A, it would be A, B, B. Replacing A with B, it would be B, A, B. Replacing again A with B, it would be B, B, A. Then if we replace the second with second, it would be A, B, B. It would remain the same. It would be again A, B, B. And if we have B, A, B, second with second, second with third, if we do, then B, B, A. And if we do something like B, B, A, second with third, it would be B, A, B. So if you observe that these two are identical, so I would be removing this. B, A, B is identical, I would be removing this. Okay. And anything more that is identical? Yes, this is identical. So now if you observe that there are fewer permutations than 6. Earlier, if everything was distinct, that is A, B, C, it was fine. But here you can see that there are fewer permutation. So we need to do something about this. So when everything was distinct, it was n factorial. But what about this case? So this case, the number of possible strings where B is repeated twice. The formula is 3 factorial divided by how much? That is 1 factorial, because 1 is used at this point, and 2 factorial. So that is why it would be 2 multiplied by 3, and this would be 1 multiplied by 2. So 1 would be won't come into picture. So the answer is 3, and yes, we can see that the answer is 3. So what did I write here? That is, this 3n is n factorial, and this is the population of the character of the first kind, that is 1 factorial, that is number of a's factorial, and this is the population of the second factorial, that is b's population, and this is known as multinomial coefficient. This is the algorithm of multinomial coefficient. So you need to understand. Let's just sum up everything in a nutshell. So if the characters are distinct, then it is n factorial. If the characters are not distinct, that is if B is coming twice and A is coming once, then n factorial divided by the population of A and multiplied by the population of B. And if it was C somewhere here also, it would have been C factorial also, and this would keep going on. Okay, so we can use this formula. Let's just reduce this. So the very first one, we can use maximum 2C and 1B. This is what we need to do. So the very first thing is that we would use only A. Okay, here comes the very first part. So only A. That is, if let's say the number 3, so that would be n factorial divided by the population of A. So if the string constitutes of only A, so if let's say there are 3 positions and everything would constitute of A, the population of A would be equal to the length. That is why this would be n factorial, which is equal to 1. This is the first one. Talking about the next one. Okay, 1A. Only A, then 1B, and rest all position. So if one position, let's say there are 3 positions, if 1 is taken by B, then there are n minus 2 position which needs to be filled by A, because we are only using 1B, we are not using C. So 1B, and I can say n minus 1 A's. So this would be nothing but n factorial divided by 1 factorial multiplied by n minus 1 factorial. Okay, we would simplify this at the end. Let's just understand this. Then if 1B is done, then just let us do the same thing for 1C. That would be, if 1C is used, then rest all position needs to be filled with A, that is n minus 1 position would be remaining. So n factorial divided by 1 factorial, that is the population of A, and the population of B, that is n minus 1 factorial. Done. 1C is also done. 1C is done. Then we have 2C. If we are using 2C, then this would be nothing but n minus 2A's if we are using 2C's. So that would be n factorial. So at this point you would see that yes, you can build out of this. N factorial divided by 2 factorial multiplied by n minus 2 factorial. So 1C is done, 1B is done, 1C is done, 2C is also done. Okay. Now 2C needs to be, so 1B with A is done, 1B and A is done, 1C with A is done, 2C with A is done. Now C, B with C, and B with 2C, and rest all positions. So these all are remaining. So these are all the combinations. I would be writing down the combination. B with 1C, B with 2C, and this is done. These are the remaining two cases that we need to handle. Okay. So 2C is also done. Now 1B, 1C. So 1B, 1C. So if two positions are filled, then we would be left with n minus 2 positions for A, and that would be n factorial divided by 1 factorial multiplied by 1 factorial multiplied by n minus 2 factorial. Fair enough. Here comes the last one, that is 2C and 1B. So 2C and 1B. This is the max we can do. So we have n factorial positions, and dividing it would be 2 factorial multiplied by 1 factorial multiplied by n minus 3 factorial. Done till this point. Now let us just simplify all of this, because we don't need to use factorials. Why? So this is equal to 1. So this is clear. So at this point, this thing is clear. So this would be what? This is n factorial, that is, let's say n minus 1. Okay, so I can write it as n minus 1 factorial multiplied by n. N factorial can be written as n minus 1 factorial multiplied by n. And this can be 1, I can ignore, and n minus 1 factorial. So I would cut both of this, which is equal to n. So this is 1 and this is n. Same goes for this side. I can again write n minus 1 factorial multiplied by n. N factorial can be written as like this. And n minus 1 factorial, I can write it like this, and this would be n. Okay. And I can write it in the same manner for this. N minus 2 factorial multiplied by n minus 1 multiplied by n minus 2. N multiplied by n. Okay. And this is 2 multiplied, because 2 factorial can be written as 2. 1 multiplied by 2, 1 I can ignore. And n minus 2 factorial, so I can remove out of this, and this is equal to n minus 1 multiplied by n is equals to 2n minus 2. Okay, and this is equal to the same thing that we did before. So 1 factorial we can simply ignore. So n minus 1 multiplied by n would be remaining. Okay. And this would be again n minus 2, because n minus 3 would be cutting it off, multiplied by n minus 1, multiply it by n. Okay, multiply it by n, and below would be just 2, because we would be ignoring this. If we multiply everything, that we have written, we can just write a plus to everything, and that would be done. Now, so let's just write this at this point. Return, first one is 1. Then we have something like n, and then we have again n. So I would be cutting this. 1 is done, n is done, and then again n is done. Okay, then 2n minus 2. Okay, that is, or I can simply write n multiplied by n minus 1. I can simply take up this and divided by 2 at the end. I can simply write n multiplied by n minus 1. Okay. This has also divided by 2, and this thing has also divided by 2. Okay, so n multiplied by n plus 1 divided by 2 Which one is done? This one is done. Now we have again n minus 1 multiplied by n. So we have n multiplied by n minus 1. Okay. Then we have something interesting, that is n minus 1. So this is again also done, n minus 1, n minus 2 multiplied by n. So we have something interesting at the end. So we would just enclose this with a bracket, n multiplied by n. So I would just write it in the same manner it is, n minus 2 multiplied by n minus 1 multiplied by n and whole divided by 2. I have written it in the same manner as it is here. Now let us just compile and run and see how many errors are we making. Seems correct. And yes, we got an AC. So to be honest, this long equation, you can again write it down in a pen and paper and you can simplify it. Like you can take out the like terms outside, then you can handle the constants and all. But you wouldn't have come up with that how this small line has came up. Okay, so this is by using multinomial coefficient. You take out all the things like this and then you need to do this. So even though the video length is small for this, so I know that this problem is a little bit confusing and I took a lot of hard work to make the video time extremely small but extremely insightful. A lot of background effort has been given to this problem to just explain you this. Okay, in front of the camera I forgot a lot of things, to be honest. So I would urge that you comment the rating of this video and leave a small comment for this, because it has been a long time I have not read out comments for me. So if you have liked it, comment it. If you didn't like it, tell me the ways to improve it. That's it for today. This is me, Siddharth Hazra, signing off. Thank you, everyone.
Hi, and welcome to Geeks for Geeks. We would be discussing the problem known as maximum sum without adjacents. So, this problem is a variation of a very standard problem of dynamic programming. So, let's just discuss this. So, here in this problem, you are given an array itself. The array is something like 5, 5, 10, 100, 10, and 5 itself. This is what is given here. Now it is told that so you need to select the subsequence. What do you mean by subsequence? Subsequence is nothing but selecting elements from between, but they should be in the same ordering as they appear. And that subsequence should be the maximum out of this. Okay. So there is one more constraint to remember, that is the numbers shouldn't be adjacent. That is, if you see 500 and then again 5, which is equal to 110. This is the very first solution to the problem. Let's see the second test case, that is 3, 3, 2, 7 and 10. If you observe here, we need to focus on 10 and we can keep a focus on 3 and the output would be 13. But if you observe this thing, this focus thing, this is the catch here. The problem is that you saw number 3 and 2, you thought that I should take 3. Then you saw the number 2 and 7, you thought I should take 7. But if you take 7, you would lose 10. Same goes for here. If you see here, you would find that here 5 and 10. If you focus on the bigger number, it might be a scenario that if you compare 5 and 10, the bigger number is 10, and selecting 10 seems to be a profitable trade. But if you select 10, then you would lose this 100, which is much more. So it might happen that if you compare two things and you take the bigger one, then selecting that bigger one and adjacent of that bigger one would have a very bigger value, which is very profitable. So this would cause all the confusion. So if you just, what is the very first thing? That if I want to increase the total sum, if I want to increase the total sum, I would focus on large elements. This is the very simplest approach you can think of. If I focus on large element, then I might lose the larger element. Okay. So you would come to the conclusion that there is no proper way to just select a way or to select all the numbers which would be maximum. Like एक certain way नहीं है, क्योंकि आप ऐसा हो सकता है अगर आप स्मॉल वाला सिलेक्ट करो तो ऐसा भी हो सकता है एंड में जाके यहाँ पर 1 ही रहे 100 के जगह. If you select, let's say, instead of selecting the large elements, you start selecting the smaller elements. It might be true for some cases, but let's say this is 1 itself. So then you would get 5, then you would get 1, and here from here you would get just 5, which is not a profitable trade. You could have made up 10, 10, and then again 5. What I meant to say is, instead of, let's say, you told Siddharth, if we can't select the larger element, I would select the smaller element. So if you select, if let's say this element, if let's say instead of here, this is 1, and you would say that I would select the smaller element. So you would select this, you would select this out of this, you would select this. And the cost would be 5 plus 1 plus 5, that is equals to 11. But the correct solution is 10, 10 and 5, which is equals to 25. So if you focus on the big elements, there would be some test cases to fail you. If you select smaller element, there would also be some test case to fail you. So there is no certain way to select the elements. So what we do in real life, let's take a very simple real life. Though if you have read Robert, so if I don't know how many of you have read, but how many of you, so if you are from a ICSE background, you would have read the poem by Robert Frost, The Road Not Taken. So here you are lost in the woods and there are two paths and you can't really find a way to select either of the path. So in real life, the way is to select is, that way to select path is that you travel both the path and whichever is better, you would select that. So we would do the same thing here. If there is no certain way of finding the maximum, find maximum subsequence, if there is no certain way, we would find all possible subsequence and we would return the maximum, and we would return the maximum sum out of those. Fair enough? So whenever we come to the conclusion that we need to explore all possible ways, explore all possible is nothing but we need to conclude that this problem is of recursion. जब भी ये कहा जाए कि सब कुछ करके देखो, तब ये प्रॉब्लम है रिकर्शन का. So now let us do this. So how would we do this? Let's just see here. 3, 2, 7, 10. Let's start from the very first index. So for the very first index, we have two options. Either to include that in our solution ought to not include that in our solution. This is take, this is not take. This is for the first index. Let's talk about the second index. The very first option is take 2. So if you take 2 after 3, this is not possible. So you can't really take 2 after 3. So you need to move forward and you need to ignore that is not take. So both would be 3 and here you have not taken 3, so you can take 2 or not take 2 because you are free to do that. Taking a particular index is a provision if you have not selected the last index. You can write a if statement here. Next, you can just do an operation from this. So now, if I have not selected the last one, so I can select 7, that would make it 3, 7. I can ignore 7. If I have selected 2, I don't have any option but to ignore 7. Okay. Now, after doing this, let's talk about the last index. So if you have taken 7, there is no provision to take 10. So we can't really take 10. We can ignore 10. That would make it just 3 and 7. If we have taken 3, then if we have taken 3, we have no provision. If we have ignored 7 in the last step, ignored the 7, so now you can take 10, 3 and 10. If we have just taken 2, so you can always take 10. So these are the probable options. The very first one is 3 and 7. Next one is 3 and 10. The next one is 2 and 10. These are the 3 options out of this. The answer would be the maximum out of this, that is 13. That is this. So the answer is 13. So this is how you would proceed. Okay. So there is 2 options for us, that is take or not take, and you would move down. So if you have solved up at coded DP contest, and that is frog jump, you would get a hint of this problem. There are many problems to this, and the major take not take is used in 0-1 knapsack. Take or not take comes into picture by 0-1 knapsack. So I would suggest you to solve that. Now if you observe that based on recursion, so recursion would be would give you a very high time complexity, and if you like write a larger test case, you would see that there are overlapping things, like we are computing the same thing for again, so we would need to memorize it. Now let's memorize it directly. First we would write the recursive and then we would just memorize it, and that would solve the purpose. So what we would do is we would write the recursive. So I would write int recursive. So we have the index int I, we have the index, and then we have the given array, that is int arr. Instead of int arr, I would just write a, because I am a very lazy person. Okay, int arr, and so we just need the index at each point. So if we have reached the very end, that is very start of that, we would return that. So if there is only one index, that is if I is equals to 0, we would return a of I. Okay. If by chance we have reached this position, that is if it is less than 0. So if there are less than 1 elements, then we can't do anything, but the answer would be 0. So if I is less than 0, so if we have only one element, we would just return that element. If we have no elements, the answer would be 0. These are the 2 base cases. Okay, done. Now comes the part when we would take this. So if we take the element, the value, we would add that value in our answer, that is a of I, and we would move to the I minus 2th index, because we can't really go to the next index. we would go to the I minus 2th index. So rec of what? I minus 2th index, and then A again. So you've had observed now, if I have selected 3, I can't go to the next index, that is 2. I need to go to the next of next index, because if I have taken 3, I can't really go to 2. That is why I minus 2. If I have not taken, int not take is equals to, I can't add up this value in my answer, but I can select the next index. That is, I have ignored this property. So if I have ignored 2, then I can add up 7 in my answer. So that would be I minus 1. That would be I minus 1 comma A. Done. Then the maximum of take and non-take would be my answer. So int answer is equals to max of take comma not take, and return the value of the answer, and that is done. Okay, so I is equals to n minus 1 comma A. Let's just compile and see how many errors are we making. My output is correct, but if you submit this, you would see an error. You would see a TLE, time limit exceeded. Why? Because at each step, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. So the time complexity of this approach is 2 to the power n. So we need to optimize over this. Optimizing over this is, I told you that many a times we are doing the same computation again. So let's take up this example. So let's take, this is me. I went up and saw a friend of mine named as Manish. I saw that his traits doesn't match with me. So I ignored him and tried to find some other person who would match, whose traits would match with me. But then I again wasted my time on Manish. So if I had remembered that Manish does not have traits like me, the next time I wouldn't have wasted my time on Manish to make friends with him. So in the same manner, if I don't want to repeat the same mistake, I need to remember my mistake. So in life, if I don't want to repeat the same mistakes, I need to remember my mistakes or the lessons learned from it. We would do the same thing here. So recursion is a very simple person. He repeats the same mistake again and again. So if I make recursion remember that this is the mistake that you have already done, and if I store it, then this would be problem. This would be easy. So now what I would do is, I would declare a vector of int dp or memo. Let's say memo of size n with everything as -1. -1 would just tell me that this position is still not tried. That let's say Ankit, I have not been a friend with Ankit. Manish, I have not been a friend with Manish. So if that value is -1, that means I have not been a friend of him. This is done. Now I would pass this memo. Now, before becoming a friend, I would check that memo of I. If that value is not equal to -1, that means I have already done friendship with him. Then I would just return the learning of my friendship from that point. I won't be friends. I won't again try to be friends with him. If I have already been a friend of him, I would just return the lesson. If I have not been a friend, then only these all statements should execute. And at the end, whatever lessons I have learned, I need to store that. Memo of I is equals to answer. Just before returning, I need to write it down in a pen and paper. Okay, and this is done. We need to pass this memo function by reference, because I need to retain the values. Vector int and memo. max of take not take. Here also I need to write memo. Here also I need to write memo. Just passing it again and again. And this should be good enough. I forgot to write the return function here. Let's just see. Now let us just submit this and see how many errors have we got. And yes, we are able to solve up this problem. So I just missed the return thing. So if you were able to learn something out of it, if you saw something that needs to be appreciated or saw something that needs to be inculcated, then positive criticism is always acceptable and appreciation would make me happier. That's it for today. If you're watching this stream in the recorded version, feel free to like and comment on the video so that the reach of this video could be increased. That's it for today. Thank you and have a nice day.
So hello and welcome everyone. I am Jadal Sanya, and in this video we are going to solve the question game of XOR. So before moving on to the video, let's keep the target of 50 likes in this video and let's start with the video. So first of all, let's try to understand the problem statement. The problem statement is pretty easy to understand. So given an array of size n, the value of an array is denoted by bitwise XOR of all the elements it contains. Find the bitwise XOR of the values of all the subarrays of A. So you will be given an array, and what you have to do, you have to find out the bitwise XOR of all the subarrays of the given array. So let's take an example which is given to us over here. So in this example, the value of n is equivalent to 3 and the array elements are 1, 2 and 3. So now what all subarrays are possible? So the subarrays possible are 1, 1, 2, 1, 2 and 3. The subarray starting with index 1 will be 2, 2 and 3 and 3. So these are the subarrays which are possible for the given array, and now we have to find out the bitwise XOR of every element, every subarray. So the bitwise XOR of this will be 1. So bitwise XOR of 1 and 2, that will be 0, 1, and this is the bitwise XOR. Let's try to find out 1, 1 and 0. So this is going to be 3. So this is 3, and now for this, what will be the bitwise XOR? So the bitwise XOR of 1, 2 is 3, and the bitwise XOR of 3 will be equivalent to, it will give you 0, and over here it will be 2. So what will be the bitwise XOR of 2 and 3? Let's try to find out. It will be 0, 0 and 1. So this will be 1, and now for this it will be 3. So let's try to find out 1 XOR 3 XOR 0 XOR 2 XOR 1 and XOR 3. So this will come out to be 2, right? So the answer for this test case comes out to be 2. Okay, and you can observe that I have find out the bitwise XOR of all the subarrays. So basically you have to find out all the subarrays and find out the bitwise XOR of each and every subarray. And whatever is the final output, you have to print it in the output. So that is the entire question, right? So I hope you understood the question. And now let's move and understand what can be done and how we can approach this solution, right? So let's start. So first of all, what I'll be doing, I'll be discussing the basic approach over here, that is the brute force approach, which comes to my mind. So try to think what can be the brute force approach. So based on the explanation of the test case, you might have guessed that we can find out each and every subarray in the given input array and find out the XOR of all the subarrays, and that would be the output. If you have thought of a solution that works that way, then absolutely you have found the brute force approach, right? So what will be the brute force approach? The brute force approach is to find all the subarrays, and do the XOR, right? So this is the bitwise XOR process. So this is how you can find out. Let's try to see the algorithm, how you can find out all the subarrays. I hope everyone knows how to find out all the subarrays. So I'll be having one loop that will be going from I is equal to 0 to I is lesser than n, right? And there will be one more loop that will be starting from j is equal to I to j is lesser than n, right? And now there will be one more for loop, and this inner for loop will be for finding the XOR of all the elements included in the range I to j. So what I did, I have iterated over the array elements for the variable I, and I have iterated over the array elements for the variable j. J will run from I to n, and I will run from I to n. Right? So what will be the inner for loop? The inner for loop will run from I is equal to 0 to basically for k is equal to 0 to k is lesser than or equal to j, and it will find out the XOR, bitwise XOR of all the elements included. So let's say I have a temporary variable inside this for loop, and that for loop will be basically, let's say this is my temporary variable. This temporary variable has been initialized with 0. So now temporary variable, I'll use it to find out the bitwise XOR of all that elements. That would be array of I. Right? So now I have found the bitwise XOR of all the elements in this manner, and this is one of the subarray which you will be finding. And now what you need to do, you need to have one result element. You need to have one result element, and that result element will be initialized to 0. And at the end, you can simply, after finding the bitwise XOR of a subarray, just do the XOR of result and the bitwise XOR which you have found over here, and that would be inside the temporary variable. So now here is the entire logic to find out all the subarrays and do the bitwise XOR, right? So this is the brute force approach, and let's try to analyze that whether this approach will work or not. So over here, if you try to observe the time complexity, what will be the time complexity of this approach? So let's try to analyze the time complexity. The outer for loop runs n number of times, the inner for loop runs n number of times, and the inner for loop, which is over here, this will also run n number of times in worst case. If that subarray includes all the elements, then this for loop will also run n number of times. So what will be the time complexity over here? Obviously, it is going to be n cube, and this time complexity will not be accepted because of the constraint. So this is the time complexity of this approach. And now what will be the space complexity? Quickly, so the space complexity comes out to be constant, as I'm not using anything that is dependent upon the input test case, right? So this is the time and space complexity. But if you have a look at the question, you will be able to understand that the time and space complexity are expected to be order of n and order of 1 respectively. That means linear time complexity algorithm is required over here, but we have found n cube, right? So we need to optimize the entire solution. Let's try to understand what can be the optimal approach. So now let's try to discuss the second approach, which is going to be the optimal approach. So in the optimal approach, before understanding the optimal approach, I would like to mention few of the properties of bitwise, right? So let's say if you do the bitwise element A and element A, that is bitwise XOR of the same elements, you will be getting 0, right? So now if you do the bitwise XOR in this manner, if you do the bitwise XOR odd number of times, you will get the element A. Let's take A is equal to 2, right? So 2 XOR 2 will be giving you 0, 0, 1, 0 and 0, 1, 0. You can observe the bitwise XOR will be equivalent to 0. Now let's say if I do the XOR 3 number of times, right? So what will be the output? It will be, see, this is 2 twice 2, right? And now that will be the result. 0 will be the result of this. And now what I'll be doing, I'll be adding one more 2. So that would be bitwise of 2 3 number of times. So that would be again 2, right? So basically, if you do the element, if you do the bitwise XOR of any element odd number of times, basically you will be getting 0. So bitwise XOR of A, and that is even number of times, even times, what you will be getting? You will be getting 0. And now similarly, if you do bitwise XOR odd number of times, you will be getting the same element. You will be getting the element A. So this is the important property, and based on this property, what I will be doing, I will be finding out my optimal approach. So please keep this in mind, that this is the important property, that bitwise XOR of any element even number of times will be giving you 0, and bitwise XOR of any element odd number of times will give you that same element. All the elements are going to be A only. Basically, let's say if you are taking 2, all the elements are going to be 2 only. So now, how will this approach, how will this observation help me out? So as I mentioned, let's take the first example which we just saw right now. So this is the first example, and now let's say, so what was the question? The question was to find out the bitwise XOR of all the subarrays of the given array, right? So basically that means you have to find out the XOR of, let's say this is the first subarray, do the XOR with the second subarray, do the XOR with the third subarray, 1, 2, 3, do the XOR with the other subarray, and keep on doing in this manner, right? So you have to include all the subarray, you have to include the elements from all the subarrays, XOR with 3, right? And what will be the output? The output over here in this scenario comes out to be 2. So basically, if you remove the brackets, so this is what it looks like. So basically, you have to find out the XOR of this many elements, right? So now over here, you can observe the elements are being repeated, right? So 1 is repeated, right? So 1 is occurring how many number of times? It is occurring thrice. So 2 is also repeated, 2 is occurring this many number of times, right? So how many times 2 is occurring? I can see 1, 2, 3 and 4. How many times? What is the frequency of 2 in this? The frequency of 2 is even. The frequency of 2 is even. 2 is having 4 as its frequency, right? So XOR of any element or even number of times will give you 0. So this will be cut, right? So this will be cut down. And now what is the frequency of 1? The frequency of 1 is what? It is equivalent to 3. It is equivalent to 3 frequency. Odd number of times. So you will be getting the same element, right? So now what is the frequency of 3? I can see 1, 2 and 3. 3 is also occurring how many times? 3 number of times. It is occurring odd number of times. So the XOR of 3 number of times will give you 3. So now what will be the XOR? Final XOR will be nothing but XOR of 0, 1 and 3. So basically 0 XOR 1 XOR. So this will be 0, 0, 1 and 0, 1, 1. What will be the output of this XOR? So the output will come out to be 2 and that is your output, right? So basically over here you need to find out that ith element, what will be the frequency of the ith element in all the subarrays possible. If you know the frequency of ith element, you can conclude whether it will be 0 or whether it will be the same element. So now let's say to observe, let's say to find out. So the important point which we just saw right now is that find the frequency of ith element in all the subarrays. So for this, let's try to observe how we can quickly find the frequency of the ith element, right? So now let's say over here, this is the entire array. A new example, 1, 2, 3 and 4. And now what I will be doing, I will be quickly mentioning all the subarrays, 1, 2, 1, 2, 3, 1, 2, 3 and 4, 2, 2, 3, 2, 3 and 4, 3, 3, 4 and 4, right? So along with this, I'll be mentioning the indexing. I is equal to 0, I is equal to 1, I is equivalent to 2 and I is equivalent to 3. Now I want to find out that whether the I is equal to 1, the element at this position, how many times is this, what is the frequency of 2 in all the subarrays? So basically I can see the 2 is occurring over here, 1, 2, 3, 4, 5 and 6. So basically if I try to find out what is the frequency of the ith element, I'll be getting a very concise formula. And what will be that formula? Let's try to observe. Okay, so now over here, this element 2, I want to find out that this element 2 can be the part of how many elements, how many subarrays. So it can be the part of this subarray, it can be the part of this subarray, that means 2, 3 and 2, 3 and 4. So on the right hand side, it can be the part of 3 subarrays. And on the left hand side, it can be the part of 1, 2 and 2. Similarly, basically I can see in the left hand side, it can be the part of 2 subarrays, right? So there can be different combinations. So on the left hand side, I can see it can be the part of 1, 2 and 2. So this is my left hand side, and what is the right hand side? It will be 2, 2, 3, 2, 3 and 4, right? So basically this can be the combination. So now over here, how to find out how many subarrays are possible? So basically you simply need to find out, this can be combined with any of this, right? It can be combined with any of this. So basically you have to find out that how many subarrays will include the ith element in the left hand side and how many subarrays will include the ith element in the right hand side, right? On the right hand side, you can see over here for this, what is the answer? The answer came out to be 3 for right hand side. For right hand side, the answer came out to be 3. So what is that value? So that value is nothing but n minus I. Try to think on this. N is what? N is equivalent to 4 in this scenario. And what is I? I is equivalent to 1, right? So this is equivalent to 1. So n minus I. What is n minus I? That is 4 minus 1 is equivalent to 3. Basically on the right hand side, there are 3 subarrays that will include 2. And on the left hand side, that would be I plus 1. I can see this and this. These are the 2 subarrays, right? So basically I plus 1, that is 1 plus 1, that comes out to be 2. And if you multiply these values, I plus 1 and n minus 1, basically as I mentioned, the cross combination can be done. So 3 into 2, that comes out to be 6, and that means that the frequency of 2 will be 6 in all the subarrays, among all the subarrays. And if you want to check, you can have a look over here. You can observe these are the 1, 2, 3, 4, 5 and 6. 6 subarrays are possible in which 2 is included, right? There are 6 subarrays in which 2 can be included. So basically this is how you can find out the total number of frequency of the ith element in all the subarrays, right? So the formula, let me just write down the formula, that is I plus 1 into n minus I. This gives you the frequency. Okay, so this gives you the frequency of ith element in all subarrays, in all the subarrays, right? So now basically you have to find out whether this frequency, let's say this is frequency of ith element, if this frequency is odd, if this frequency is odd, then what does it mean? It will contribute the same element in the XOR. So basically, let's say if you will be having the result element, right? So that you will be simply doing the XOR with the result element. Result XOR ith element, array of I. And if it is equivalent to even, if that frequency is even, then what you have to do? You have to simply ignore it, because the XOR of even elements, basically even number of times, will be equivalent to 0. That is the entire observation, right? I hope you understood every observation. Now let's try to have the look at the implementation part. So over here I've implemented the entire algorithm in Java, but the same can be implemented in other languages as well. So I have used one result variable initialized to 0 that will be storing the final result. Now I have iterated over every element. I'm trying to find out the frequency of ith element. So frequency will be I plus 1 into n minus 1, right? Left hand side multiplied with the total number of possibilities in the right hand side. And now if the frequency is odd, then only the ith element will contribute in the result. So I have done the XOR with the result of the ith element. If it is equivalent to even, then obviously it will be reduced down to 0. So I'm not including it, right? And at the end, you simply need to return the result variable. So let's try to submit it, and let's try to see the acceptance. And while it is getting accepted, what will be the time and space complexity? Try to think. Obviously, it is observable that the time complexity in this scenario comes out to be linear, because we have only a single for loop, right? So the time complexity comes out to be order of n, and the space complexity comes out to be order of 1. So that is the entire part. And we can see that the problem has been successfully submitted. So that was it for in this video. I hope you really enjoyed the solution, and do hit the like button and share it with your friends. I will be seeing you in the next video. Thank you. So hello and welcome everyone. I am Jay Dalsania, and in this video we are going to study the question rightmost different bit. So this question is very easy to understand. It has not got much complexity. So without wasting any time, let's start the video. So what is the question? First of all, let's try to understand what the question is trying to say. So in this question, you will be given two numbers m and n, and you have to find out the position of the rightmost different bit in the binary representation of the numbers. If both m and n are the same, then you have to return -1 in that scenario. Okay, so let's try to understand with this example go over here, which is given to us. So the value of m, let's have a look at the example. So if the value of m is equivalent to 11 and the value of n is equivalent to 9. So basically what you have to do, you have to find out the rightmost bit which is different in both of them. Okay, so first of all, what will be the binary representation of 11? It will be something like 1, 0, 1, 1, 8 plus 2 plus 1, 9, 11, right? And what will be the binary representation of the 9? It will be 1, 0, 0 and 1, right? So this is the right side of this binary representation. So one by one, let's compare which is the different bit. So this is same and this is different. So this is the first bit, this is the second bit. So the output for this test case comes out to be 2. So you have to print out which is the rightmost bit and which is the different one. And now let's take one more example for better understanding. So this was example 1 and example number 2. So let's take the example given in the question. It is m is equal to 52 and n is equal to 4. So m is equal to 52 and n is equivalent to 4. What will be the output? Let's have a look at the output. So before that, let's have the idea about the binary representation of 52 and the binary representation of 4. So the binary representation of 52 is 1 1 0 1 0 0, and for this 4 it will be 1 0. It will be something like this, right? So one by one, let's have a look at the rightmost bit. So this is the first bit, similar, similar, similar. This is also same, and this bit is not same. So which is that bit? 1 2 3 4th and 5th. Fifth bit is not same. Basically they are different, so the output for this test case comes out to be 5. You can have a look at the quotient as well. Both the outputs are matching. So this is how you have to find out the rightmost different bit. So the question was not that difficult to understand. Now here comes how will you implement this part. And the implementation is also very easy. Basically the logical part is also very easy. And let's have a look at the logical part. So basically, first of all, what we need to understand, one thing we need to keep in mind before understanding the approach. So that thing is that any number, let's say a, if I do the logical AND operation with a, basically a and 1 will give you what? It will give you 1 or it will give you 0. So what will be the output? How can be the output be 1 and 0? So let's say if the value of a is equivalent to 8, that will be this 1, 3 times 0. And now if I do the AND operation with 1, so 1 will be this. And let's say 8 is what? This is your 8. So if you do the binary AND operation, you will be seeing that the output comes out to be 0. The output comes out to be 0. So basically that denotes that this last bit of 8 is equivalent to 0. If the output of AND operation with 1 is equivalent to 0, that means the last bit of 8 is 0. And now let's say if there was 9 instead of 8, and if I do AND with 1, you will see that the output comes out to be 1. So basically 1 will be the output whenever the last bit is 1, and 0 will be the output whenever the last bit is 0 of that number a. Right? So based on this property, what I will be doing, I'll be comparing the value of 8, basically the value of variables m and m. So what I'll be doing, I will keep on iterating. So basically let's take an example. Let's say if the value of, let's say this example, 11 and 9. So let's say this is 11 and this is 9. So we know the binary representation of 11 is 1 0 1 1. And what is the binary representation of 9? It is equivalent to this 1 0 0 and 1. So now I will do that if the value of m and n, basically if the value of m and 1 is equivalent to the value of n and 1. So basically that denotes if the last bit is same, then what I will be doing, I will be deleting the last bit from both of them. So basically I will check if the last bit is same, then I delete the last bit. So all the bits will be shifted to the right position by 1. Okay, so now let's do one by one. So I'll check if m and 1, so basically 11 and 1 and 9 and 1, what do you think will be the value? It will be 1, both of them. You can observe over here, and with 1, this will give you what? It will give you 1, and the AND operation with this one will also give you 1. So basically what will be the output? The output comes out to be 1 in both the same, both the bits are same. So I will do the right shift of both of them. So I will do the right shift. M is equivalent to right shift by 1 and n is equal to right shift by 1. And along with that, one more thing I will be using, that is the bit position. I will be checking whichever bit is not equivalent at that position, what is that position. So basically I'll use one variable, position variable, and whenever I see the value of basically the bits are same, I'll increase the value of position by 1. Okay, and then I'll be doing the right shift. Okay, so this process will be continued each and every time until and unless both of them are having different bits. Right, so now doing the right shift of both of them, so this bit will be discarded. So this is the entire remaining binary representation. So what is this binary representation? This binary representation now changes to, this is 1 2 and 4, this is 5 and this is 4. So now doing the AND operation, again AND operation, 1 and AND, it will give you what? It will give you 1. Okay, so basically this thing we did, and now again with this 4, if I do 4 and 1, I'll be getting 0 in this scenario. So basically, let me write down over here. So if I do 5 and 1, I will be getting 1, and if I do 4 and 1, I will be getting 0. So over here, the value, this condition is not satisfied, that AND operation with 1 for m and m does not give you the same bit. So this is the thing where I will stop the iteration. This is the point where I'll stop the entire iteration and I'll just come out of this entire loop. And on coming out of this entire loop, I know that the value of this position variable has now been increased to 1. So I'll increase the value of position again by 1. And I will say that this is the position where both the bits are different. Okay, and what will be the value? The value comes out to be 2. So let me write down the entire algorithm in a clear manner so you can have a understanding. Position is equivalent to what? Initialized with 0. And now the value, I'll be using a while loop, while m and 1. And basically this is equivalent to n and 1. If this is the scenario, I will increment the value of my position variable and I'll do the right shift of m and n. So m right shifted by 1 and n will be right shifted by 1 as well. Okay, and at the end you simply need to do +1. You simply need to do the +1 with position and return it. Okay, so this is the entire algorithm. And now let's have a look with one more test case so you can have more understanding. So let's say both the values, let's say m in this scenario comes out to be 5 and n comes out to be 2. So binary representation of 5. What is binary representation of 5? It is 1 0 1, and for 2 it is this one 0 1 0. So now I will do the operation m and 1. So m and 1 and n and 1. So what will be the value? It will be 1 for this scenario, it will be 0 for this. I can see the AND operation with 1 for m and n comes out to be different. So at that point, I know the value of position variable will be initialized to 0 and this loop will not be executed. Control comes out of the loop and I'll be returning position +1. So position +1 will be 1. So the first position from the right hand side is the place where both of them are having different values, different bits. So this is how the entire algorithm works. A simple iteration over the bits, and one by one you will be right shifting all the bits by one position. So basically this is the entire algorithm. Pretty simple algorithm and pretty straightforward. Two things only done. Basically AND with 1 and do the right shift. Okay. So now let's have a look at the implementation part. And before moving to the implementation part, try to guess what will be the time and space complexity in this scenario. So the time and space complexity depends upon which number is having more number of bits. Okay, so let's say if m and n, over here you can observe, let's say m is equivalent to 52 and n is equivalent to 1. So obviously this 52m will be having more number of bits. Okay, so the time complexity depends upon whoever is having maximum of log of m or log of n. Okay, so this is the entire time complexity. And what will be the space complexity? Space complexity is constant. Nothing fancy, nothing extra has been used. That depends upon the input test case size. Okay, so that was it for the entire algorithmic part. So now let's move to the implementation part. So over here I've implemented this entire thing in Java, but the same can be implemented using other languages. Take the reference of the algorithm which I have shown. And now over here I have written down one more statement that if m and n both of them are same, I'll be returning minus. So try to think on this statement. Do you guys agree? Let's say m and n both of them are having value 2. So both of them will be having same binary representation. So obviously it's not possible that any of the bit might be different in both of them. So I have handled that scenario over here in the beginning itself and I'll be returning -1 over here itself. Right? So now if you do not handle it over here, now you need to handle it differently over here in this while loop, because the while loop will keep on going infinitely. So this condition is very much important. Okay, so now I have used the position variable to denote the position, and now I'll be checking if m and 1 and n and 1 are equal or not. If they're not equal, then position variable will be increased and both of them will be done right shift by 1. This continues until the bits are different, and whenever the bits are different, the return statement position +1 will be executed. So let's try to submit the same and let's try to have a look at the acceptance. And we can see that the problem has been successfully submitted. So that was it for in this video. I hope you really enjoyed the solution. So thank you for watching. I will be seeing you in the next video. Bye bye.
Hello everyone, my name is Karan Masru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is modified game of name. First of all, let us start by understanding the question. What does question say? You are given an array A of n elements. There are two players, player 1 and player 2. So there are two players and we have an array A of n elements. A player can choose any of element from an array and remove it. Okay, so in one move, player can choose any of the element from array and remove it. If the bitwise XOR of all the remaining elements equals to 0 after removal of the selected element, then that player loses. So basically, if there are, let's say, k number of elements at present and player 1 removes an element, and if the XOR of the remaining k-1 elements becomes 0, then that player loses who last picked the element. Okay. Find out the winner if player 1 starts the game and they both play their best. So player 1 will start and they will give their best. Okay, they will play optimally. For example, here the second player is a winner. Why? Because let's say if the first player picks 3, then the remaining is 2 and 3. Their XOR is not 0. So game is not over. Then player 2 picks up either 3 or 2. So remaining will be 1 element. Then player 1 again picks up the last element and then the set becomes empty. So the XOR is 0. So player 1 loses and 2 wins. Okay. Here player 1 wins. Why? Because the XOR is already 0. Okay. So when it's already 0, so player 1 is winning the game. Okay. Since the XOR of an array is already 0, player 1 wins. You do not need to read input or print anything. Your task is to complete the function find winner, which takes the number n and the array A as input parameters and returns an integer denoting the winner. The expected time complexity is big O of n and expected auxiliary space is constant. So now if we think about solving this problem, so basically see, we have an array A which contains n elements and two players are playing a game, player 1 and player 2. They both give their best. Okay. And player 1 starts the game and then the turns are alternative. So 1, 2, 1, 2 and so on. Now, let's say these are the n elements of the array. If the XOR of all the elements is already 0, then in that case, player 1 wins the game. Okay. If the XOR is not 0, then whenever whichever player turn is there, they can remove any element from the array. So let's say player 1 removed this element. Now, if the XOR of the remaining elements becomes 0, then the player who last made the move loses. So player 1 will lose. But if the XOR of the remaining element is not 0, then the player 2 gets the chance to play. Now let's say player 2 removed this element. Player 2 also can remove any element. Now if the XOR of the remaining elements becomes 0, then in that case player 2 loses because player 2 made the last move and player 1 wins. So this game continues until at some point of time XOR of the remaining elements becomes 0, then the last player who made the move loses. Or if the array becomes empty, in that case also we believe that the XOR of the remaining elements is 0. So the last player who removed the element will lose. Okay, and the other player will win. So now we need to tell, given an array of n elements and two players 1 and 2, we need to return the integer of the player who will win. If 1 will win, we will return 1. If 2 will win, we will return 2. Now see, we cannot solve, one of the ways will be to solve it brute force. Okay, so by brute force, what we need to do is recursively call all possibilities. So let's say player 1 removed this or 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 this. So we will call all the recursions. Then in that further, there will be a lot of recursion. So there will be a lot of cases and the time complexity will be very high and it will give time limit exceeded. So we need to think of something more efficient. So what we will do is we will take small examples and try to build it up and try to get some pattern or something and solve the question. Okay. Let's say n is 1. There is only one element. Okay. So now also let's divide all the cases into two parts. One, if the XOR of the initial array, if the XOR of the initial array is 0, okay, so let me write it like this. If the XOR initial is 0 or it is not 0, okay.